Is it audible? Voice okay?
ఇట్లా ఓకే
మనకు కాదు పిల్లలు.
వాళ్ళకి ఇప్పుడు మనం స్టార్ట్ చేశాక
అండ్ వాల్యూమ్ పెంచడానికి students voice, is it audible and clear? I mean loud. Voice, is it audible? Good evening everybody, my voice, is it clear and audible? Okay, fine, thank you.
Yes, sir.
Good evening students, let's continue the last class. So yesterday we have one more singular point. That one more singular point is essential singular point. Essential singular point. Listen to me. Essential singular point means statement of the given problem does not have any separate denominator. Statement of the given problem doesn't have any separate denominator, and at the same time, if series expansion possible for that, and that series expansion contains infinite number of negative powers of z minus z naught, then z naught is called essential singular point. Remember, statement of the given problem does not have any denominator. In that case, if possible, that series expansion contains infinite number of negative powers of z minus z naught, then z naught is called essential singular point. Suppose series expansion not possible, and at the same time it doesn't have denominator and the series expansion not possible, then it has no singular point. It has no essential singular point. It has not at all a singular point only. Right on. If the function has no denominator, if the function has no denominator, and it's a series expansion contains infinite number of negative powers of z minus z naught, means infinite number of terms in the principal part. infinite number of terms in the principal part infinite number of negative powers of z minus z naught in the Laurent series expansion about z is equal to z naught then z naught is called an essential singular point. Next slide. Then z naught is called an essential singular point. Listen to me, essential singular point can be determined by writing the series expansion only. By writing the series expansion only, essential singular point can be determined. Example, f of z is equal to e to the power of 4 by z minus 2. So we know e to the power of x expansion, that is 1 plus x square by 2 factorial plus x cube by 3 factorial plus so on. So this is f of z is equal to e to the power of x. E to the power of x means 4 by z minus 2. Expansion should be 1 plus x plus x square by 2 factorial plus so on up to infinity. This is equal to 1 plus 4 by z minus 2 as it is plus this is 16 by 2, 8 by z minus 2 whole square plus so on. And observe, we have infinite number of negative powers of z minus z naught. We have infinite number of negative powers of z minus z naught. So z naught is called essential singular point. Z naught means 2. Therefore, z is equal to z naught. Z naught means 2 is called an essential singular point. See, essential singular point like that also. Here no particular criteria. Here also series expansion only. Here also series expansion only. Today's syllabus will be completed our complex variables. And now be careful. Next concept. and most important concept as well, residues. So residue definition, the coefficient of 1 by z minus z naught in the Lorentz series expansion. The coefficient of 1 by z minus z naught in the Lorentz series expansion is called residue of f of z at z is equal to z naught. What I said? The coefficient of 1 by z minus z naught. The coefficient of 1 by z minus z naught in the Lorentz series expansion. In the Lorentz series expansion, in the Lorentz series expansion about z is equal to z naught is called residue of f of z at z is equal to z naught. Once again, for today's class, this is the first one for today's class. First slide. Second slide. Third slide. Next. So 1 by z minus z naught coefficient in the Lorentz series expansion is called residue of f of z at z naught. Anyhow, let us write the Lorentz series. I am writing the Lorentz series. Lorentz series is sigma n is equal to 0 to infinity an into z minus z naught whole to the power of n plus sigma n is equal to 1 to infinity bn z minus z naught whole to the power of n. This is the Lorentz series. I will write in the next slide. F of z is equal to sigma n is equal to 0 to infinity an into z minus z naught whole to the power of n. Now expand the second part of the Lorentz series by taking n is equal to 1, 2, 3, so on. Take n is equal to 1 here, then it is b1 into, take n is equal to 1, then it should be b1 into z minus z naught whole power minus 1. Take n is equal to 2, then it is b2 into z minus z naught whole power minus 2 plus so on. From this, f of z is equal to sigma n is equal to 0 to infinity an into z minus z naught whole power n plus b1 into 1 by z minus z naught plus b2 into 1 by z minus z naught whole square plus so on. Everyone should remember the coefficient of 1 by z minus z naught in the Lorentz series expansion is called residue. This is the coefficient of 1 by z minus z naught. So this is called residue of f of z at z is equal to z naught. 1 by z minus z naught coefficient in the Lorentz series expansion is called residue of f of z at z is equal to z naught. Do you know, yesterday I gave an value and bn value of the Lorentz series, but I need only bn value. Yesterday I gave an value, bn value of the Lorentz series. I just need only bn value. What is that bn value? Integral f of z by 1 by 2 pi I into f of z by z minus z naught whole power minus n plus 1 into dz. This is bn value. But what is residue? Residue is 1 by z minus z naught coefficient. That is only b1 is called residue. To get b1 value, take n is equal to 1 here. If I take n is equal to 1 here, b1 is equal to 1 by 2 pi I f of z by z minus z naught whole power minus 1 plus 1. Minus 1 plus 1, 0. Z minus z naught power 0, 1. Integral f of z dz. 1 by 2 pi I into integral f of z dz. So finally, residue means integration of f of z dz multiplied by 1 by 2 pi I is called residue. F of z means force, dz means displacement, integration means total. So total work done by a force in displacing a particle around a closed curve into 1 by 2 pi I is called residue of f of z at z is equal to z naught. That is the definition of residue. Now let us see the definition of residue at different singular points. At different singular points. Residues. First definition. Residue at removable singular point. Residue at removable singular point, and everyone should listen to me carefully. Removable singular point means suppose there are no negative powers of z minus z naught in the Lorentz series expansion. No negative powers of z minus z naught in the Lorentz series expansion. Z naught is removable singular point. Look here everyone. Be careful. No negative powers of z minus z naught means there are this term does not exist. No negative powers of z minus z naught means sigma n is equal to 1 into bn z minus z naught whole power minus n does not exist. If it does not exist, your Lorentz series will be sigma n is equal to 0 to infinity an z minus z naught power n. That's it. Residue definition 1 by z minus z naught. Residue definition 1 by z minus z naught. If there are no negative powers of z minus z naught, then there will not be 1 by z minus z naught. Because 1 by z minus z naught means z minus z naught power minus 1 only. No negative powers in the Lorentz series expansion, then z naught is called residue. Sorry, removable singular point. If there is no negative power, then we cannot find the residue, because residue definition 1 by z minus z naught coefficient. So residue at removable singular point will be 0. If z is equal to z naught is a a removable singular point then residue of f of z at z is equal to z naught will be 0. Now residue at pole, residue at pole. So we have different cases. If z naught is a pole of order 1, what will be the residue? If z naught is a pole of order 2, what will be the residue? First case, if z is equal to z naught is a pole of order 1, pole of order 1 means pole of order 1 means simple pole. Then next slide. Then next slide. Residue of f of z at z is equal to z naught will be limit z minus z naught into f of z as z tends to z naught. As z tends to z naught. Or in case of simple pole, we can find residues like this also. Sometimes we have f of z is equal to phi of z by psi of z, where phi of z and psi of z have no common factors, where phi of z and psi of z have no common factors. If phi of z naught, remember z naught is a singular point. If phi of z naught not equal to 0, comma psi of z naught is equal to 0, and psi dash of z naught not equal to 0, then phi of z naught not equal to 0, psi of z naught 0, psi dash of z naught not equal to 0, then residue of f of z at z is equal to z naught. Z naught is a simple pole. Please do remember, is equal to phi of z by is equal to phi of z by psi dash of z at z is equal to z naught, is equal to phi of z by psi dash of z at z is equal to z naught. These two formulas are valid only when z naught is a simple pole. Simple pole, pole of order 1. Next slide. If z is equal to z naught is a pole of order 2. then a residue of f of z at z is equal to z naught is equal to limit z tends to z naught d by dz of z minus z naught whole square into f of z. If z is equal to z naught is a pole of order 2, you can use that. Similarly, if z is equal to z naught is a let us generalize pole of order m, then a residue of f of z at z is equal to z naught is equal to 1 by m minus 1 factorial into limit z tends to z naught d power m minus 1 by dz power m minus 1 means m minus 1 times the differentiation of z minus z naught whole to the power of m into f of z. Here z is equal to z naught is a pole of order m. If you take m is equal to 1, you will get pole of order 1. M is equal to 2, pole of order 2. M is equal to 3, pole of order 3. So on. So this third formula is the generalized formula. Please remember that. Next. Residue at essential singularity. Singularity or singular point both have same meaning only. Remember everyone, residue definition. Everyone listen. Residue definition, residue at essential singular point definition, same. Because residues at essential singular points will be found from residue definition only. If z is equal to z naught is an essential singular point, a residue of f of z at z is equal to z naught is equal to coefficient of one by z minus z naught in the Laurent series expansion. About z is equal to z naught. 1 by residue definition only. Residue at essential singular point and residue definition same. Because we can find residue at essential singular point with the help of definition only. Now we do problems. Problem number 1. The residue of complex function x of z is equal to 1 minus 2z by z into z minus 1 into z minus 2 at its poles. This problem given in the GATE Electronics Engineering 2010. And 1 minute, listen to me. Whenever the series expansion possible, give the first priority for writing the series expansion and identify 1 by z minus z naught coefficient to find its residue. Whenever the series expansion not possible, then only you can find the residues with the help of the formulas I gave. Now denominator is equated to 0. Whatever the z values you get, these z values are called singular points. So z is equal to 0, comma 1, comma 2 are the singular points. But one thing, denominator is equated to 0. Whatever the z value you get, substitute that z value in the numerator. In case numerator not equal to 0, that z value is called as pole. If I take z is equal to 0 in the numerator, numerator is 1. If I take z is equal to 1 in the numerator is minus 1. If I take z is equal to 2 in the numerator, 1 minus 2 into 2, 1 minus 4, minus 3. Numerator not equal to 0. Then these z values are called poles. But frankly saying simple poles, I mean poles of order 1. Any pole that repeats only one time, that is called a simple pole. All are repeated only one time. So which are the simple poles? But don't use any formula. Residues at simple poles directly found in this manner. Suppose you want to find the residue at x, z is equal to 0. To find the residue at z is equal to 0, z is equal to 0 pole is obtained from this part of the given function. So to get the residue at z is equal to 0, delete this part from the given function. Delete this part. This part means z. Delete this z from the given function and put z is equal to 0 in the remaining part of the function. Put z is equal to 0 in the remaining part. That is 1 minus 2 into 0 by 0 minus 1 into 0 minus 2, that is 1 by 2. Now residue of x of z at z is equal to 1. Z is equal to 1 pole is obtained from this part of the given function. Z is equal to 1 pole is obtained from this part of the given function. So delete this part from the given function and substitute z is equal to 1 in the remaining part. That is 1 minus 2 into 1 by 1 into 1 minus 2. 1 minus 2 into 1 by 1 into 1 minus 2, the answer should be 1. So residue of x of z at z is equal to 2. Z is equal to 2 simple pole is obtained only from this part of the given function. So simply delete this part, I mean z minus 2. After deleting this z minus 2, substitute z is equal to 2 in the remaining part only. That is 1 minus 2 into 2 by 2 into 2 minus 1. That is 1 minus 2 into 2, 1 minus 2 into 2 by 2 into 2 minus 1. That is minus 3 by 2. This is the way to calculate the residues only at simple poles. Only at simple poles. Problem number 2. Consider the complex valued function f of z is equal to e power iz by z into z square plus 1. Find the residue at the pole lies in the upper half plane. Upper half plane means y greater than 0 is. See, you are not asked to find the residues at all the poles. You are asked to find the residue at the pole that lies in the upper half plane. Upper half plane. Look there. On x-axis, y value 0. On x-axis, y value 0. On y-axis, x value 0. Upper half plane means area above x-axis. Remember what I am saying. Upper half plane means area above x-axis, including x-axis or excluding x-axis. Both are upper half planes only. Area above x-axis, including x-axis or excluding x-axis, both are upper half planes only. Area above x-axis means area above y is equal to 0. Area above y is equal to 0 is y greater than 0. Y greater than 0. Y greater than 0 means excluding y-axis. Y greater than or equal to 0 means area above x-axis, including x-axis, including x-axis. Excluding x-axis here, including x-axis. And remember, upper half plane means area above x-axis, either including x-axis or excluding x-axis, but area above x-axis. This is upper half plane. And you all people know lower half plane. Lower half plane means area below x-axis. Lower half plane means area below x-axis, either including x-axis or excluding x-axis. That would be lower half plane. No issue. On x-axis, so area below x-axis means y less than 0, because on x-axis y value 0. On x-axis y value 0, below x-axis means y less than 0. But one thing, y less than 0 or y less than or equal to 0. Y less than 0, y less than or equal to 0, no issue. In the similar manner, we can write left half plane, right half plane in the same manner. Now take the given function. E power iz by z into z square plus 1. Now z square plus 1 can also be written as z plus I into z minus I. Z square plus 1 can also be written as z plus I into z minus I. Its value z square plus 1 only. Denominator is equated to 0. Whatever the z values you get, these z values are called singular points. These are the singular points. Now, as we discussed already, every complex number should also be represented by point form. Every complex number should also be represented by point form. A real part x coordinate, imaginary part y coordinate. A real part x coordinate, imaginary part y coordinate. Real part x coordinate, imaginary part y coordinate. These are the singular points. Now you observe this. This is x-axis. In this statement of the problem, look, in this statement of the problem, we were given y greater than 0. Y greater than 0 means excluding x-axis. Y greater than or equal to 0 means including x-axis. Y greater than 0 means excluding x-axis. On x-axis, y value 0. On y-axis, x value 0. Now, the singular points 0, 0. This is 0, 0. And this is I. I means 0, comma 1. Next, this is minus I, means 0, comma minus 1. Now, we need to consider the singular point that lies in the upper half plane. Only one singular point lies in the upper half plane because we were given y greater than 0. So excluding x-axis, the singular point on the x-axis will not be considered because the condition given y greater than 0 and at the same time upper half plane as well. So only we need to consider this. We should not consider this. So you need to find a residue of f of z at z is equal to I. Z is equal to I simple pole is obtained from this part of the given function only. This first one. Z is equal to I simple pole obtained from this part of the given function. Then delete this part and substitute Z is equal to I in the remaining part. Substitute Z is equal to I in the remaining part. That is e to the power of I into I by denominator is I into I plus I. E power I into I, that is e power I square. I plus I 2I into I, that is 2I square. So e to the power of I square value minus 1. E power minus 1 by denominator I square value minus 1 into 2 minus 2. Therefore, this is minus 1 by 2e. Next problem. Problem number 3. The residues of the function f of z is equal to 1 by z minus 4 into z plus 1 whole cube r. This problem given in the GATE Electronics Engineering 2017. So denominator is equated to 0. Whatever the z values you get, substitute these z values in the numerator. If numerator not equal to 0, your substituted z value is called as pole. Z is equal to 4. Substitute z is equal to 4 in the numerator. We don't have z. So numerator 1, non-zero number. Therefore, z is equal to 4 is a simple pole. Because 4 repeated only one time, that's why. Next, z plus 1 is equal to 0, z is equal to minus 1. Substitute in the numerator, z is equal to minus 1 in the numerator, numerator not equal to 0. Therefore, z is equal to 0 is a pole of order 3. Because minus 1, z is equal to minus 1 repeated 3 times, because it is z plus 1 whole cube. Residues at simple poles will be found directly. Z is equal to 4 simple pole is obtained from this part of the given function. So delete this part, means delete z minus 4 and substitute z is equal to 4 in the remaining part, that is 1 by 4 plus 1 whole cube. That is 1 by 5 cube, that is 1 by 125. Calculation of residues in this manner is valid only when z is equal to z naught is a simple pole. Suppose z is equal to z naught is a pole of order 3, then a residue of f of z as z tends to z naught. I have already given the formula z is equal to z naught is a pole of order m. You apply this formula, z is equal to z naught is a pole of order m. Take m is equal to 3, 3 minus 1, 2. Take m is equal to 3, 3 minus 1, 2. Limit z tends to z naught. D power m minus 1, 3 minus 1, 2. That means d square by dz square into z minus z naught whole cube, z minus z naught whole power m value 3 into f of z. But we need actually residue of f of z is required at z is equal to minus 1. Z naught value minus 1. So this is 1 by 2 into limit z tends to z naught d square by dz square, z naught value minus 1, z minus of minus 1, that is z plus 1 whole cube into f of z. What is f of z? 1 by z minus 4 into z plus 1 whole cube. Now z plus 1 whole cube, z plus 1 whole cube cancel each other. Next slide. 1 by 2 into z naught value minus 1. So this is equal to 1 by 2 into limit z tends to minus 1. D square by dz square, no. First, let us differentiate first time, means one time. One time differentiation of 1 by x. 1 by x derivative minus 1 by x square. Assume it as x. 1 by x derivative minus 1 by x square. And differentiate one more time. So that is 1 by 2 into limit z tends to minus 1. One more time. Z power z minus 4 power minus 2. Z minus 4 power minus 2. Derivative minus 2 into minus 1 plus 2. Minus 2 into z minus 4 whole power minus 2 minus 1. That is minus 3. So take z is equal to these two cancel. Take z is equal to minus 1. Then it is minus 1 minus 4 whole power minus 3. That is minus 5 whole power minus 3. That is 1 by minus 5 whole cube. That is 1 by minus 125. 1 by minus 125. So that is minus 1 by 125. Next. Problem number 4. Find the residues of f of z is equal to 1 by z sin z. At its poles. So to get the residue, simply denominator should be equated to 0. One minute. To find the residue at its poles, 1 minute. Inside the circle, problem not yet completed. Inside the circle, x square plus y square is equal to 1. You need to find the residues at the poles which are lying inside the circle only. How many poles lying inside this circle? Let me check. First two denominator is equated to 0. That's fine. Z sin z is equal to 0. That is z is equal to 0. And sin z is equal to 0. Z is equal to 0 is okay. Sin theta is equal to 0. I will write, otherwise you may forget. Sin theta is equal to 0. So theta is equal to n pi, where n belongs to integers. Sin theta is equal to 0. Therefore, theta is equal to n pi, where n is integer. Integers means 0, plus minus 1, plus minus 2, so on. Z is equal to 0. Take n is equal to 0 first. Integers means 0, plus minus 1, plus minus 2, plus minus 3, so on. Take n is equal to 0. 0. Take n is equal to plus 1, plus pi. N is equal to minus 1, minus pi. N is equal to plus 2 pi, minus 2, minus 2 pi, plus or minus 3 pi, so on. Remember, everyone be careful. Here z is equal to 0 is repeated 2 times. Observe, z is equal to 0 is repeated 2 times. Here and here. Therefore, substitute z is equal to 0 is a singular point. Substitute z is equal to 0 in the numerator not equal to 0. Therefore, z is equal to 0 is a pole, but it is repeated twice. So, it is a pole of order 2. Pole of order 2. And it is lying inside the circle. Pole of order 2 lying inside the circle. X square plus y square is equal to 1. Have a doubt? Remaining singular points. Next slide. Next slide. Z is equal to plus or minus pi, plus or minus 2 pi, plus or minus 3 pi. Lie outside the circle. X square plus y square is equal to 1. This is x square plus y square is equal to 1 circle. This is 0, 0 point. Z is equal to pi. Pi value 3.14. But our radius of the circle is 1 only. Z is equal to 3.14 lying outside. Z is equal to 2 pi. 2 pi means 2 into 3.14. That is 6.28 will lie outside because our circle radius maximum 1 only. That's why pi value 3.14, 2 pi value 2 into 3.14, 3 pi value 3 into 3 into 3.14, all will lie outside. So we need to calculate the residue at z is equal to 0 only. Z is equal to 0 is a pole of order 2. Everyone use the formula for pole of order 2. Pole of order 2 formula, limit z tends to z naught d by dz of z minus z naught whole square f of z. This is the formula for pole of order 2. We are calculating the residue at z is equal to 0. Find the residue at z is equal to 0. So limit z tends to 0 d by dz of z minus z naught value 0, z minus 0 whole square into f of z, that is 1 by z sin z. Here 1z, here 1z cancel. Apply u by v rule. Apply u by v rule. vu dash minus uv dash. Numerator is u, denominator is v. U means z, v means sin z. So v into u derivative means z derivative 1 minus u into z into v derivative, sin z derivative cos z, by v square is there, v square is there, by v square. Now v square means sin z whole square. Sin z whole square, that is sin square z. Again 0 by 0 form. If I take z is equal to 0, it will become 0 by 0 form. 0 by 0 form, apply L'Hospital rule. Sin 0, 0 minus 0 into cos 0 by sin 0, 0 by 0 form. Apply L'Hospital rule. Applying L'Hospital rule means differentiate the numerator and the denominator with respect to z. Sin z derivative cos z minus apply uv rule. This is u, this is v. U v derivative z into cos z derivative minus sin z. So z into minus sin z. U v derivative plus v u derivative, that is cos z into z derivative 1 by denominator, numerator derivative, denominator sin square z. First to treat it as z only. Treat it as z. Z square derivative 2z means sin z. And again sin z derivative cos z. So limit z tends to 0, cos z minus into minus plus z sin z minus into plus minus cos z by 2 sin z cos z. Now cos z cancel. Limit z tends to 0. Still we have z sin z by 2 sin z cos z. And again sin z cancel. Take z is equal to 0. If I take z is equal to 0, then answer will be 0. 0 by 2 cos 0, 0 by 2, answer 0. Please remember that. Next problem. f of z is equal to z minus 3 into sine of 1 by z plus 2. Then the residue of f of z at z is equal to minus 2 is option A minus 5, option B plus 5, option C 0, option D 1. Don't try to solve as per the procedure. This is what is the residue definition? The coefficient of 1 by z minus z naught. The coefficient of 1 by z minus z naught in the Laurent series expansion is called residue of f of z at z is equal to z naught. The coefficient of 1 by z minus z naught in the Laurent series expansion is called residue of f of z at z is equal to z naught. Now let me explain. First concentrate. Look here. And everyone, here z naught value minus 2. Z naught value minus 2. 1 by z minus z naught. 1 by z minus of minus 2. Z minus z naught means minus 2. Z minus of minus 2, z plus 2. So directly we did this problem yesterday. Residue of f of z at z is equal to minus 2 is coefficient of 1 by z minus z naught. Coefficient of 1 by z minus z naught. Z naught means minus 2. Minus into minus 2 plus 2. In the Laurent series expansion. About z is equal to minus 2. And everyone must listen to me carefully. Yesterday, I have already given the Laurent series expansion of z minus 3 into sine of 1 by z plus 2 about the point z is equal to minus 2. Let us go back and check. Yesterday, I already gave Laurent series expansion of z minus 3 into 1 by z plus 2. Z minus 3 into 1 by z plus 2. Look here everyone. Expand z minus 3 into sine of 1 by z plus 2 about z is equal to minus 2. About z is equal to minus 2. Look, this is the Taylor series expansion. Everyone observe. 1 by z plus 2 coefficient is the residue. What is 1 by z plus 2 coefficient? 1 by z plus 2 coefficient is simply minus 5. 1 by z plus 2 coefficient is simply minus 5. One by z plus 2 coefficient is simply minus 5. Without solving, directly we have written this. Next. Problem number 6. the residue of the function 1 minus e power 2z by z power 4 at its pole. Option A, option B, option C, option D. And this problem given in the gate, sorry, not gate, engineering services examination, prelims 2018. That is what I am saying. Whenever the series expansion possible, give the first priority for series expansion only. If series expansion not possible, then only you can calculate the residue as per the procedure or the formulas I gave earlier. So you are given 1 minus e power 2z by z power 4. That is 1 by z power 4 into series expansion. 1 minus, what is e to the power of x expansion I gave? E power x expansion 1 plus x square by 2 factorial plus x cube by 3 factorial plus 1. This is e power x expansion. Write this expansion until we get 1 by z minus z naught coefficient. Until we get 1 by z minus z naught coefficient. E power x means 2z. That is 1 plus 2z. 1 plus x plus x square by 2 factorial plus x cube by 3 factorial. Series expansion is required up to the terms containing 1 by z minus z naught only. Now, next slide. Next slide. 1 by z power 4 into 1 minus into 1. 1 minus 1 minus into plus 2z, that is minus 2z, minus into plus minus, minus into plus minus 2z whole square, 4z square by 2, 4z square by 2, that is 2z square, minus into plus minus 2z whole cube, 8z cube, 8z cube by 3 factorial, 8z cube by 6, that is 2 4s 2 3s, minus 4 by 3 z cube. So multiply each and every term of the bracket function with 1 by z power 4 minus 2z by z power 4 minus 2 by z cube minus 2z square by z power 4 minus 2 by z square minus 4 by 3 z cube by z power 4, that is minus 4 by 3z, minus so on. This is minus 2 by z cube can now be written as z minus 0 whole cube. Z square can now be written as z minus 0 whole square. Z can now be written as z minus 0. Remember the coefficient of 1 by z minus z naught. The coefficient of 1 by z minus z naught is called residue. Residue of f of z at z is equal to z naught. Z naught means 0. that is 1 by z minus z naught coefficient. 1 by z minus z naught coefficient is minus 4 by 3. Problem number 7. The sum of residues of f of z is equal to sin z by z cos z at its singular points z is equal to pi by 2 and z is equal to minus pi by 2 is dash. See, by equating denominator to 0, we get the singular points. Z is equal to pi by 2 and z is equal to minus pi by 2 are the singular points. If I take z is equal to pi by 2 in the numerator, sin pi by 2, numerator not equal to 0. If I take z is equal to minus pi by 2 in the numerator, sine of minus pi by 2 not equal to 0. Minus sine pi by 2 minus 1 not equal to 0. Therefore, these are called simple poles because each number repeated one and only one time. That's why these are called simple poles. So find the residues. Residue at the simple pole. Residue at the simple pole formula I gave already. This is the simple pole residue. Limit z minus z naught f of z as z tends to z naught. This is residue at the simple pole. Residue of f of z at z is equal to pi by 2. That is limit z tends to pi by 2 into z minus z naught value pi by 2 sin pi by 2 divided by z cos z sin z. If I take z is equal to 0, if I take z is equal to pi by 2 minus pi by 2, numerator 0. If I take z is equal to pi by 2, denominator is cos pi by 2, 0. So 0 by 0 form, apply L hospital rule. Applying L hospital rule means differentiate the numerator and the denominator with respect to z. Applying L hospital rule means numerator and denominator should be differentiated with respect to z. So UV rule, z minus pi by 2 as it is, sin z derivative cos z plus sin z as it is, z minus pi by 2 derivative with respect to z is 1 by UV rule, u into v derivative, z into cos z derivative minus sin z plus cos z into z derivative 1. If I substitute z is equal to pi by 2, let us see what happens. Z is equal to pi by 2 minus pi by 2 cos pi by 2 plus sin pi by 2 by denominator minus pi by 2 sin pi by 2 plus cos pi by 2. This term 0, sin pi by 2, this term 1, cos pi by 2, this term 0, sin pi by 2, this term 1. So numerator 0 plus 1, 1, denominator minus pi by 2 plus 1, minus pi by 2, 1 by minus pi by 2, that is minus 2 by pi. In the same manner, find the residue at other singular point also, then you will get plus 2 by pi. I'm not finding the second one. You need to find the second one in the same manner. Means same story, in place of pi by 2, please substitute minus pi by 2. You will get 2 by pi. Similarly, the residue of f of z at z is equal to minus pi by 2. Try yourself. I will not be teaching that. Try yourself. You will get it as plus 2 by pi. Plus 2 by pi you will get. Sum of residues minus 2 by pi plus 2 by pi 0. Sum of residues minus 2 by pi plus 2 by pi 0. The residue of f of z is equal to 1 plus e to the power of z by z cos z plus sin z at z is equal to 0 is a denominator is equated to 0. If you have a doubt, observe this. Denominator is equated to 0, you will get a z value. Of course, z value we were given, but why again I am equating denominator to 0 is z is equal to 0 is a simple pole or pole of order 1, just for cross verification only. So z cos z is equal to minus sin z. Now cos z will go that side. Cos z will go that side. Z is equal to minus sin z by cos z minus tan z. Remember everyone, z is equal to minus tan z. Z is equal to minus tan z. Z value minus tan z value same only when z is equal to 0. Only when z is equal to 0. Z is equal to minus z is valid only when z is equal to 0. The above condition is valid only at z is equal to 0. So z is equal to 0 is a simple pole. So residue of f of z at z is equal to 0 is limit z tends to 0 into z minus 0. Z minus 0 means z. Z minus z naught into f of z. Z naught means 0. 1 plus e power z by z cos z plus sin z. 0 by 0, apply L'Hospital rule. 0 into 1 plus e power 0, 0. 0 into cos 0 plus sin 0. 0 by 0, apply L'Hospital rule. Differentiate the numerator and denominator. Z into 1 plus e power z derivative with respect to z e power z plus 1 plus e power z as it is, z derivative 1. Denominator z into cos z derivative minus sin z. So z into minus sin z plus cos z into z derivative 1 plus sin z derivative cos z. Take z is equal to 0. 0 plus 1 plus e power 0, 1 minus 0 into sin 0 plus cos 0 plus cos 0. Answer ultimately 1. Note this and try. Residue of f of z is equal to 2 plus 3 cosecant z by z. Yet z is equal to 0 is dash. Don't directly solve. Don't solve it directly. First write cosecant z as 1 by sin z. First write cosecant z as 1 by sin z. And then take LCM. And then solve as per the procedure. And then verify. Write cosecant z as 1 by sin z. Take LCM. And then simplify. Remember, z is equal to 0 is a polar factor 2. Z is equal to 0 is a polar factor 2. Answer 2. Try later. Find the sum of residues of f of z is equal to e power z by z square plus z square plus pi square whole square. Z square plus pi square whole square at its poles lying inside the circle mod z is equal to 4. Remember, the same problem I gave in Cauchy's integral formula. There it is very lengthy. The same problem can be solved very comfortably using Cauchy residue theorem. But to solve any problem using Cauchy residue theorem, we must know residues. So that's why let us find the residue here. The same residue let us apply in Cauchy residue theorem in order to get the answer and in order to get the value of this integral easily. As compared to integral formula, it is comfortable to solve using residue theorem. right? What is the given function? Z square plus pi square whole square. Z square plus pi square. Z square plus pi square will be written as Z plus pi I into Z minus pi I. Remember, Z square plus pi square value Z plus pi I into Z minus pi I whole square. This is Z plus pi I whole square into Z minus pi I whole square. So denominator is equated to 0. We got the Z values. These Z values are called singular points. Substitute these singular points in the numerator. Numerator not equal to 0. Therefore, e power pi I not equal to 0, e power minus pi I not equal to 0. So these two are poles of order 2. Because the whole square is there, no? So same root will be repeated twice. Poles of order 2. Every complex number should also be represented by point form. Both singular points lying inside the closed curve only. This is Z is equal to 0, 0. This is Z is equal to 2 because circle is Z is equal to 4. This is Z is equal to singular point 0 comma 2 minus 2 comma 0 0 comma minus 2. Now 0 comma pi. Pi means 3.14. Pi means 3.14. Sorry, singular points are radius 4, no? Okay, fine. Radius 4 minus 4, radius 4, so it is plus 4, radius 4, this is minus 4, minus 4 plus 4. So 0 comma pi, pi value 3.14. This is the point 0 comma pi means pi I. This is the point, this is 0 comma minus 4. Therefore, this is 0 comma minus pi. Pi value 3.14. That's why. So both singular points lying inside the closed curve only. So we need to find the residues at both singular points. I mean at both poles. Residue of f of z at z is equal to pi I, which is a pole of order 2. So it should be limit z tends to z naught d by dz of z minus z naught whole square into f of z into f of z, that is e power z by z plus pi I whole square z minus pi I whole square, z minus pi I whole square z minus pi I whole square, cancel. So u by v rule apply, limit to z tends to pi I, u by v rule z plus pi I whole square into e power z derivative e power z minus e power z into z plus pi I whole square value 2 into z plus pi I e power z by z plus pi I whole square. Take z is equal to pi I plus pi I whole square e to the power of pi I plus pi I e power pi I by pi I plus pi I whole square. 2 pi I whole square. 2 pi I whole square is 4 pi square I square, means minus 4 pi square e power pi I minus 4 pi I e power pi I. Pi I plus pi I 2 pi I 2 pi I whole square 4 pi square I square minus 4 pi square. So numerator common factor 4 numerator common factor 4 pi e power pi I. Hmm. 4 pi e power pi I into, still we have 4 pi common, and do one thing, take out minus 4 pi, minus 4 pi common, e power pi I common, e power pi I common, minus 4 pi common, still we have pi plus I, that is minus 4 pi square e power pi I, that is minus 4 pi I e power pi I by minus 4 pi square, minus 4 pi square. So minus 4 cancel, 1 pi cancel. Pole of order 2, please verify, not simple pole method, it is a pole of order 2, whole square is there, no? Still we have e power pi I into pi plus I. Denominator power 4, let me check. Denominator whole power 4, denominator whole power 4, denominator whole power 4. Now 2 pi I whole power 4. Let me verify the denominator. 2 pi I whole power 4, that is 2 power 4, that is 16. 2 power 4 16, pi power 4 16, 2 pi I power 4 1, and the numerator simplify the second case. Second case I will not be teaching. Numerator minus 4 pi e power pi I common, minus 4 pi e power pi I common. Still what we have in the numerator, pi plus I by 16 pi, 16 pi power 4, 2 pi I whole power 4, 2 power 4, pi power 4, I power 4, 16 pi power 4. Here 4 ones, 4 fours, 1 pi cancel. Still we have minus 1 by 4 pi cube pi plus I into e power pi I. E power pi I value minus 1. Look there. I will simplify here itself. E power I theta. E power I theta formula. E power I theta is equal to cos theta plus I sin theta. So e power I pi is equal to cos pi plus I sin pi. Cos pi value minus 1, sin pi value 0. So e power I pi value minus 1. So here e power I pi is there. Write this e power I pi as minus 1, minus 1 into this minus plus. So that is 1 by 4 pi cube into pi plus I. Try the second case. After simplifying the second case, tell me the answer. We need sum of the residues. Sum of the residues. Try the second case also. Here, similarly, a residue of f of z, yet z is equal to minus pi I. Simplify this and let me know the answer. Simplify and let me know the answer. Finally, write the sum of the residues. Finally, write sum of the residues. Try yourself. Finally, calculate sum of the residues. Next. After this, I will give the break. Find the sum of residues of f of z is equal to e power z tan z. Find sum of the residues of e power z tan z. Get the poles lying inside the circle mod z is equal to 2. After this problem, I will give you the break, just 10 minutes or 15 minutes maximum. The given function is f of z is equal to e to the power of z and z. You only find the answer of the 10th question and sum of the residues. Please let me know the answer. F of z is equal to e power z tan z. This is equal to e to the power of tan z can now be written as sin z by cos z. Denominator is equated to 0. Answer 1 by 2 into pi I square. Pi square by 2 na? Okay, pi square by 2 answer. Okay, let me check. First two denominator is equated to 0. That is cos theta is equal to 0. I have already given formula for cos theta is equal to 0 yesterday. Cos z is equal to 0. Then cos theta is equal to 0, so that theta is equal to 2n plus 1 into pi by 2, where n belongs to integers. So cos z is equal to 0, therefore z is equal to 2n plus 1 into pi by 2. Denominator is equated to 0. Whatever the z values you get, substitute those z values in the numerator. In case of numerator not equal to 0, then these z values are called singular points. Numerator obviously not equal to 0. So, but among these z values, how many z values will lie inside the given circle? Let us check. Because you need to find the residue at the poles such that those poles should lie inside the circle only. If I take n is equal to 0, this is pi by 2. Pi by 2. If I take n is equal to 1, n is equal to 0, pi by 2. If I take n is equal to minus 1, 2 into minus 1, minus 2 plus 1, minus 1 into pi by 2. And next n is equal to 2. N is equal to 1. 2 into 1, 2, 2, 3 pi by 2. 3 pi by 2 value, 3 by 2, 1.5, 1.5 into pi, 3.14. 3 pi by 2 means 3 by 2 into 3.14. Pi value 3.14. So 3 by 2 into 3.3 pi by 2 value will lie outside. 5 pi by 2, 7 pi by 2, all. By taking n is equal to 1, it becomes 3 pi by 2 will lie outside the circle only. Only these two will lie. Only these two will lie inside the circle mod z is equal to 2. Find the residues at these 2 points only. Center of the circle 0, 0. What are the singular points? Pi by 2. Pi value 3.14. 3.14 by 2. Approximately 1.6. So this is pi by 2 inside. This is minus pi by 2 inside. These are simple poles. Z is equal to pi by 2 and Z is equal to minus pi by 2 are simple poles. Find the residue. Residue of, and all of you, please listen to me. Just for the sake of convenience, I will apply this formula. I have given two formulas for residue. Now for convenience, I am applying this formula. F of z is equal to phi of z by psi of z. And all of you, please verify this formula that I gave already. Residue of f of z at z is equal to z naught should be. This is comfortable now. You can apply the first formula or this formula, no issue, whichever you feel comfortable. I am comfortable with this formula. That's why I am using this. Or else you can use the first formula that I gave already. Residue of f of z at z is equal to plus pi by 2 is equal to phi of z. Phi of z means this numerator is phi of z. And the denominator is psi of z. So this is phi of z as it is. Psi dash of z. Psi of z is cos z. Cos z derivative minus sin z. And all of you please verify I gave this formula also. Yet z is equal to z naught. Z naught is pi by 2. So sin z cancel. Minus symbol will go numerator minus e power pi by 2. Similarly, I will find residue of f of z at z is equal to minus pi by 2. Same story, in place of plus pi by 2 substitute minus pi by 2. Same formula, this one, last but one. In this same last but one formula, z is equal to pi by 2, no? Now z is equal to minus pi by 2. In this formula, e power z by minus symbol, minus e power z when z is equal to minus pi by 2. Minus e power z when z is equal to minus pi by 2. Same formula, z is equal to minus pi by 2. So, sum of residues is equal to e power pi by 2 minus e power pi by 2. I think you people know this formula. Sin h theta is equal to e to the power of theta minus e power minus theta by 2. So 2 sin h theta is equal to e power theta minus e power minus theta. And apply the second formula. Sin h theta is equal to e power theta minus e power minus theta by 2. 2 will go this side. 2 sin h theta is equal to what you are asking, I don't know. Where is sin gone? Here, a denominator is psi of z is cos z. Cos z derivative minus sin z. This minus into minus will go numerator, e power z value pi by 2. Now I am finding at minus pi by 2. So same story, minus e power minus pi by 2. Simple. This is equal to, observe this, e power theta minus e power minus theta. That is 2 sin h theta. 2 sin h theta, that is pi by 2. Let's continue after the break. We'll continue after the break. Both terms are negative. Yes. Okay, 1 minute, 1 minute, 1 minute. Both are negative. Sorry, 1 minute. A small modification, both are negative. So this is minus pi, no issue. 1 minute. Both are negative, no. That is minus pi. Sorry, it's my mistake. Both are negative. Take out minus symbol. So it is minus symbol into e power pi by 2 plus e power minus pi by 2. Small mistake. Look, cos h theta. Please apply cos h theta formula. Cos hyperbolic theta is equal to e power theta plus e power minus theta by 2. By cross multiplication, 2 will go left side. Then it is 2 cos h theta. 2 cos hyperbolic theta is this. Now this is minus into e power theta plus e power minus theta, that is cos h minus into 2 cos h theta. We'll continue after the break. Let me check. Answer is correct only, no? Minus 2 cos h pi by 2. That's it. What I gave correct answer, man. Please verify. Minus e power pi I by 2. Minus e power pi I by 2. Minus e power pi I by 2. Yes, the second one is minus e power minus pi I by 2. We'll continue after the break. Don't enter anything. If any mistake is there at the end, we will verify. Welcome back to the session. And this is the last topic and most important topic also. And remember, all Cauchy's integral theorem, integral formula problems can also be solved using Cauchy residue theorem. Sometimes the problems can be solved easily using integral theorem and integral formula. Sometimes the problems can be solved easily using residue theorem. Whenever you feel any problem that is to be complicated, that is complicated, if it is to be solved using integral theorem and integral formula, then you can solve the same problem using Cauchy residue theorem and vice versa. Because but all integral theorem, integral formula problems can also be solved using residue theorem and vice versa. So the last topic, heading Cauchy residue theorem. Remember, all integral theorem, integral formula problems can also be solved using Cauchy's integral theorem and integral formula. Cauchy residue theorem. Yesterday fourth point incomplete. This is yesterday fourth point not incompleted. I have already given. If you unnecessarily enter unnecessary story, I will not check. I will directly start. Then it will impact. Some students, as soon as they enter the class, no, their motive is continuously raising hand only. The same students it is displaying here. I can remember the names also. This is the third point, man. That's your fault. This is the fourth point. This is fourth point only. This is fourth point only. This is fourth point only. Okay, let us go back. And draw this curve. There are infinite number of negative powers of z minus z naught. And these are the singular points. See, we have, this is not to design. We have finite number of singular points. These dots will represent singular points. How many? Don't count. Finite number of singular points. So f of z is analytic function inside the given closed curve and also on the given closed curve, except at a finite number of singular points which are lying inside the closed curve. Then we can use this theorem right down. If f of z is analytic, f of z is analytic function inside and on the closed curve, inside and on the closed curve. C, except at a finite number of points. Except at finite number of points inside C, then integral f of z dz is equal to 2 pi I into sigma r plus, where sigma r plus is equal to sum of residues at the singular points inside C. Remember, we need to find the residues at the singular points which are lying inside the closed curve only. We have to find the residues at the singular points which are lying inside the closed curve only. Don't find the residue at any singular point that lies outside the given curve. We have to find the residues at the singular points which are lying inside the given curve only. Problems? Remember, all integral theorem, integral formula problems can also be solved using residue theorem and vice versa. Sometimes integral theorem, integral formula complicated, then residue theorem would be helpful. Sometimes residue theorem is complicated, integral theorem, integral formula will be helpful. Whichever you feel comfortable in the exam, apply that formula. The value of, problem number 1, the value of, this is the previous slide. The value of integral e to the power of z tan z dz where C is the circle mod z is equal to 2 is, listen to me, already what is the formula? Formula is 2 pi I into sigma r plus. Sigma r plus means what? Sum of the residues at the singular points lying inside the closed curve only. Look here everyone. This sum of the residues, look, sum of the residues at the singular points lying inside the closed curve mod z is equal to 2. Sum of the residues of e power z tan z at the singular points or poles inside the circle mod z is equal to 2. Already found in the previous model. Previous model, last problem, that one only. Same problem I gave. So directly sum of residues, sum of residues we found already. What is sum of residues? Minus 2 into cos h pi by 2. Minus 2 into cos h pi by 2. Therefore, by Cauchy residue theorem, integral f of z dz is equal to 2 pi I into sigma r plus. I will write in the next slide. Next slide. That is integral e power z tan z dz is equal to 2 pi I into sum of the residues. Sum of the residues is minus 2 cos h pi by 2 that we already found in the previous model. This is minus 4 pi I cos h pi by 2. Next. Problem number 2. Evaluate integral dz by z sin z, where c is x square plus y square is equal to 1. This problem, Engineering Services Examination Prelims Paper 2017. Even this problem also we have found. Actually, according to this problem cannot be solved using Cauchy's integral theorem, Cauchy's integral formula. To solve one problem using Cauchy's integral formula, your denominator should be z minus z naught. But from sin z, we cannot, sin z cannot be in the form of z minus z naught. So integral formula is not applicable. So residue theorem formula 2 pi I into sum of residues. 1 by z sin z, 1 by z sin z, sum of residues we have already found in the previous model. Look here, 1 by z sin z, sum of residues already found. Look, 1 by z sin z, we are asked to find the residues at the poles lying inside the circle. X square plus y square is equal to 1. Right now our problem also circle x square plus y square is equal to 1. But only one pole z is equal to 0 lying inside the circle. So we need to find the residue at that pole. What is residue? For this problem we found residue at residue 0. Problem number 4 on residues. Residue 0. Residue 0. Residue at z is equal to 0 is 0. Example number 4 on residues. Even the previous problem also, example number 11. On residues. Now, directly integral dz by z sin z is equal to 2 pi I into sum of residues. 2 pi I into sum of residues 0. Problem number 3. Evaluate integral z square sine 1 by z where c is x square plus y square is equal to 1. Problem number 4 you can try. evaluate integral z cube cos 1 by z where c is x square plus y square is equal to 1. Problem number 4, try yourself. Remember, problem numbers 3 and 4 cannot be evaluated using Cauchy residue cannot be evaluated using integral theorem or integral formula. For integral theorem, integral formula, denominator should be z minus z naught. So we don't have z minus z naught. Therefore, integral theorem, integral formula not applicable. Residue theorem is comfortable. So f of z is z square into sine 1 by z. We know sin x formula. I have already given sin x formula earlier. Apply that. X minus x cube by 3 factorial plus x power 5 by 5 factorial minus so on. Now this is z square into sin x. X means 1 by z. That is x minus x cube by 3 factorial plus x power 5 by 5 factorial minus so on. Remember, expansion is required up to the terms containing 1 by z minus z naught only. Expansion required up to the terms containing 1 by z minus z naught, because 1 by z minus z naught coefficient will be the residue then. So this is equal to z square into 1 by z minus 1 by z whole cube by 3 factorial. That is 1 by 3 factorial z cube plus 1 by z power 5 by 5 factorial. That is 1 by 5 factorial z power 5 minus so on. Multiply each and every term of the bracket function with z square. Z square by z, z minus 1 by 6 z square plus 1 by 5 factorial means 120 z square by, this is z, z square by z power 5, that is z cube. Z should now be written as z minus 0. Z cube, I can write it as z minus 0 whole cube. This is z minus z naught. This is z minus z naught. 1 by z minus z naught coefficient in the Lorentz series expansion is called residue of f of z at z is equal to z naught. So residue of f of z at z is equal to z naught. Z naught is 0. That is minus 1 by 6. 1 by z minus z naught coefficient minus 1 by 6. But one thing, your z naught value, your singular point value must lie inside the circle, because we need to calculate the residues at the singular points which are lying inside the circle only. According to Cauchy residue theorem, residues will be calculated at the singular points which are lying inside the given circle. That is mandatory. Of course, our singular point is z is equal to 0, means 0 comma 0 lying inside the given curve only. Therefore, by Cauchy residue theorem, integral z square sine 1 by z dz is equal to 2 pi I into sum of the residues, that is minus 1 by 6. That is 2 ones, 2 threes. Therefore, the answer is minus pi I by 3. What is problem number 4 answer? Problem number 4, z cube cos 1 by z, z cube cos x, that is 1 minus x square by 2 factorial plus x power 4 by 4 factorial. 1 by z, 1 by z power 4. So 1 by 24, 1 by 24 into 2 pi I, that is 12, pi I by 12. Fourth problem answer, pi I by 12, pi I by 12. Problem number 5. The value of integral e power 1 by z divided by z dz, where C is the circle mod z is equal to 2. You can solve this problem using integral theorem, integral formula, or residue theorem, whichever you feel comfortable. I want to solve this problem using residue theorem. As I told you already, is there any possibility to expand any given function as a Laurent series? First, to expand the given function as a Laurent series and then identify 1 by z minus z naught coefficient as a Laurent series. E to the power of x, e power x, x value 1 by z. E power x, x value 1 by z, that is 1 plus x plus x square by 2 factorial plus so on. Of course, simple problem only. So e power 1 by z divided by z is equal to, take this 1 by z or 1 by z into 1 plus x square by 2 factorial, 1 by z whole square, 1 by z square by 2 factorial, 1 by z square will come down, that is 1 by 2 factorial into z square. So 1 by z into 1 plus 1 by z into z plus 1 by z into 2z square, 2z cube. So 1 by z minus z naught coefficient. That's why write z as z minus 0. 1 by z minus z naught coefficient is called residue. That's why write z as z minus z naught. So residue of f of z at z is equal to z naught means 0 is equal to 1 by z minus z naught coefficient, that is 1. But z naught is a singular point, should lie inside the given circle. Z0 is a singular point inside the given circle. That is mandatory because your singular point Z0 value must lie inside the given curve. Suppose your singular point lying outside the given curve, you should not find the residue at that singular point. Our singular point is Z0 is equal to 0. It is lying inside the curve, so no issues. Every time, please check whether the singular point inside or outside. That is compulsory because we just need residues at the singular points lying inside the curve only. Therefore, by Cauchy residue theorem, integral f of z dz, f of z means e power 1 by z divided by z, is equal to 2 pi I into sum of the residues, that is 2 pi I into 1, that is 2 pi I. Next, an integral capital I over a counterclockwise circle means anti-clockwise means positive direction, circle counterclockwise circle C is given by z square minus 1 into e power z by z square plus 1 dz. If capital C is defined as mod z is equal to 3, then the value of capital I is, I will write in the next slide, next frame. Option A minus pi I sin 1. Option B minus 2 pi I sin 1. Option C minus 3 pi I sin 1. Option D minus 4 pi I sin 1. This problem given in the GATE Electronics Engineering 2017. First of all, assume the given integrand as f of z. Integrand is z square minus 1 into e power z by z square plus 1. Denominator z square plus 1 is also written as z plus psi into z minus psi. Denominator is equated to 0. Whatever the z values you get, those z values are called singular points. Substitute z is equal to I in the numerator, that is I square, that is minus 1 minus 1 minus 2 into e power I, so not equal to 0. Similarly, substitute z is equal to minus I in the numerator, minus I whole square, so that is I square, that is minus 1 minus 2 into e power minus I, not 0. Therefore, these are the simple poles. Every complex number should also be represented by point form. You need to calculate the residues at the poles which are lying inside the given closed curve only. Center of the circle, I think the given circle is mod z is equal to 3. So radius 3. This point should be 3 comma 0. It should be 0 comma 3. It should be minus 3 comma 0 because radius 3. 0 comma minus 3. So 0 comma 1. This is 0 comma 3. 0 comma 1 will be here. 0 comma minus 1 will be here. So both singular points lying inside the given closed curve only. So find the residues at the singular points which are lying inside the closed curve. Moreover, these are simple poles. So residues can be found easily at simple poles as we discussed at very beginning of today's session. A residue of f of z at z is equal to I. Residue of f of z at z is equal to I. Z is equal to I simple pole is obtained from this part of the given function. So assume that this part is deleted and substitute z is equal to I in the remaining part of the given function, means this part, z square minus 1 e power z by z plus psi. Substitute z is equal to I in the remaining part of the given function, e power I, denominator I plus I. So this is I square value minus 1 minus 1, that is minus 2, by denominator I plus I 2I into e power I. Moreover, do one thing, multiply and divide by I. So I want to eliminate I from the denominator, that's why multiply and divide by I. This is minus 1 by I e power I, multiplying and dividing by I, so it is minus I by I square e power I. I square value minus 1. So minus I by I square value minus 1 e power I. So this cancel. Then it is I e power I. I into e to the power of I. E power I, see, e power I can be written as e power I into 1. E power I can be written as e power I into 1. Do you know e power I theta formula? So e to the power of I theta is equal to cos theta plus I sin theta. E power I can now be written as e power I into 1. I can be written as I into 1. So theta should be 1. Then it is cos 1 plus I sin 1. So this is I into cos 1 plus I sin 1. So this is I into cos 1, I into I square value minus 1 into sin 1. This is the residue at z is equal to I. Similarly, I will write in the next slide. Similarly, let us find the residue at z is equal to minus I. Residue of f of z at z is equal to minus I, that is equal to z is equal to minus I simple pole is obtained from this part of the given function. Z is equal to minus I is obtained from this part. Assume that this part has been deleted and substitute Z is equal to minus I in the remaining part. This. So it should be minus I whole square minus 1 e power minus I by minus I by minus I whole square, that is I square, that is minus 1 minus 2 minus I minus 2I e power minus 2 cancel, then it is 1 by I into e to the power of minus I. To simplify that, multiply and divide by I. So it is I by I square into e power I square value minus 1. I by minus 1, that is minus I e power I. Sorry, minus I e power minus I. Now, e power minus theta formula, as you people all know, cos theta minus I sin theta. Cos theta minus I sin theta. Now we need e power minus I into 1. So theta value 1. So it should be cos 1 minus I sin 1. Substitute there. This is equal to minus I into e power minus I value cos 1 minus I sin 1. So this is minus I into cos 1, that is fine. Minus into minus plus I into I square value minus 1 into sin 1. Now sigma r plus means sum of the residues. First residue I cos 1 minus sin 1. Sum of the residues I cos 1 minus sin 1. Now this is minus I cos 1 minus sin 1. Now plus I cos 1 minus I cos 1 cancel. Now minus sin 1, that is minus 2 sin 1. Therefore, by Cauchy residue theorem, integral f of z dz means z square minus 1 into e power z by z square plus 1 into dz is equal to 2 pi I into sigma r plus, that is 2 pi I into sigma r plus minus 2 sine 1. That is ultimately minus 4 pi I sine 1. Option D is the right answer then. In the same manner, note this problem and try yourself. Problem number 7, note it down and try. Integral tan z dz, where C is mod z is equal to 2. Try yourself it later. Answer is minus 4 pi I. Cauchy residue theorem completed. Syllabus also completed. Few basics only. Syllabus completed. Up to here only syllabus. Syllabus completed. Few basics means we were covered. Just wait for 15 minutes so that I can stop the class. A few more problems from the basics. What we have in volume 1 in our practice booklet, z minus 3 by z plus 3 less than 2 represents. Wait for 15 minutes just to stop the class. Syllabus completed. Set of all points yes, it is tan z, man. Any confusion? It is tan z. It is tan z by mistake. Okay, fine. Thank you very much. Tan z dz. Set of points inside the circle x plus 5 whole square plus y square. 15 minutes, please bear with me. Option B. Set of all points outside the circle x plus 5 whole square plus y square is equal to 16. Set of all points inside the ellipse x square by 2 plus y square by 3 is equal to 1. Set of all points outside the ellipse x square by 2 plus y square by 3 is equal to 1. Next slide. Next slide. This is magnitude of z minus 3 by z plus 2, sorry, z plus 3. Z minus 3 by z plus 3 less than 2. So modulus of z minus 3 by modulus of z plus 3 less than 2, because modulus of z1 by z2 is equal to mod z1 by mod z2. Now modulus of z plus 3 will go right, that is less than modulus of z plus 3. Z means x plus iy minus 3 less than 2. Z means x plus iy plus 3. And this is x plus 3 plus iy, of course x minus 3. Write the real terms in one bracket, less than, write the real terms in one bracket, x plus 3 iy. Remember, modulus of one complex number is square root of real part whole square plus imaginary part whole square. Modulus of one complex number is square root of real part whole square plus imaginary part whole square. This is for left part, means this. Similarly, for right part, less than modulus of one complex number is square root of real part whole square plus imaginary part whole square. Now squaring on both sides, x minus 3 whole square plus y square less than 4 into x plus 3 whole square plus y square. And you observe clearly this left hand side y square, right side y square cancel. Left y square, right y square cancel. X minus 3 whole square, x square minus 6x plus 9 less than 4 into x plus 3 whole square, x square plus 6x plus 9. So x square minus 6x plus 9 less than 4 into x square, 4x square, 4 into 6x, 24x plus 4 9s are 36. Now take the left side to the right, 4x square minus x square. Take left side to the right, 4x square minus x square, 3x square. Minus 6x will go right side, 24x plus 6x, 30x. Plus 9 will go right side, 36 minus 9, 27. Divide both sides by 3, divide both sides by 3. 0 less than 3x square by 3, 30x by 3, 27 by 3. This is x square plus this is x square plus 10x plus 9 greater than 0. Now you cannot solve. Please verify it is brought to which of the following 4 options. It is brought to which of the following 4 options. Let me check. First option A, x plus 5 whole square. Option A, let us verify first. X plus 5 whole square. X plus 5 whole square is x square plus 10x plus 5 plus 25 plus 25. Y square is there. Oh, sorry, y square cannot cancel. Okay, fine, students, got it. Y square cannot cancel. Fine. It cannot cancel. No issues. You proceed. That is 4y square. Now this is plus y square. No issue, a small correction. 4x square. Left side also y square will be there. No, x square minus 6x plus 9 plus y square. X square minus 6x plus 9 plus y square. 4x square plus 24x plus 36 plus 4y square, and take 0, 3x square, 30x, 27, 4y square minus y square, that is plus 3y square plus y square. Now it is being written as plus y square greater than 0. According to the options, I can write it as x plus 5 whole square. That is x square plus 10x plus 25. We need to compensate that. Plus 25 plus y square is equal to 16. Look there, x plus 5 whole square, x square plus 10x plus 25. 25, 16 goes to left side. 16 goes to left side, minus 16. 25 minus 16, that is plus 9 only. So greater than 16, greater than 16. And everyone should listen to me carefully. Circle equation is x minus h whole square plus y minus k whole square is equal to r square. Circle equation is x minus h whole square, h value minus 5, minus into minus 5 plus 5 plus y minus k whole square is equal to r square is equal to 4 square. So this is a circle. Center circle center at minus 5 comma 0 and the radius 4. Remember, greater than means outside, less than means inside, is equal to means on the circle. Resulting answer greater than right side number outside the circle, less than right side number inside the circle, is equal to right side number on the circle. We have greater than 4 square. So finally it is outside the circle, outside the circle. One more problem, I'll stop. One more problem. Write this. Given a complex number is also called as vector z, then z e power I alpha where alpha is a real number where alpha is a real number, amounts to option A, scaling of z, by a factor alpha. Option B, rotation of z anti-clockwise. Rotation of z anti-clockwise through an angle alpha. Rotation of z anti-clockwise through an angle alpha. Next, reflection of z by a factor of alpha about x-axis. Next, to translation of z to the point z is equal to alpha. Just 5 minutes only, simple problem. It will take 5 minutes and I'll stop. After that, I'll take the doubt session and I'll give my mobile number, and if you have any queries, you can contact, and mail number, mail ID also I'll give. Draw this x-axis and this is y-axis. And what is z? You are given z is equal to ZBA. Only 5 minutes I will stop. Only 5 minutes. Let z be a complex number. Suppose you don't know how to solve any problem regarding complex variables, immediately convert your complex number into polar form. Unable to find the solution of any complex number, convert that complex number into polar form. Z is equal to x plus iy is a complex number. In polar form, it should be r e power I theta, as we discussed on the introduction day class. Now, theta is called argument of z. Theta is called argument of z. We need z into e power I alpha. Multiply both sides of the equation by e power I alpha. First, listen to me. Everyone, z. Z means what? This is. Look there. This is the point. This is the z. Z means what? R e power I theta. R e power I theta. Radius. R means what? Root of x square plus y square. That root of x square plus y square. R means radius. This is the radius. Radius of the complex number is this. So let this point be P. This is z is equal to, listen to me, in polar form, x plus iy complex number. This is x plus iy. Its polar form is r e power I theta. This is r e power I theta. Radius of the vector is r. Theta is the angle. Look there. Theta is the angle. What is the angle it is making? Theta. Now multiply both sides of the given z by e power I alpha. Z e power I alpha is equal to e power I alpha into r e power I theta. So r as it is, here bases same, e powers will be added. That is I alpha plus I theta. So this is e power I into theta plus alpha. Remember everyone, z complex number is making an angle theta, with positive x-axis. But z e power I alpha, making an angle theta plus alpha. Up to here, this is theta. And be careful what I'm saying. If this line is making an angle theta with positive x-axis, then another line is making an angle theta plus alpha. Theta plus alpha means if it is theta plus alpha, next line should be above this line only, r line only, because z is equal to r e power I theta line will making an angle theta with x-axis, but z into e power I alpha making an angle theta plus alpha. This is theta. Theta plus alpha means another line should be above this r line only. Above r line only. So therefore, what is this? It is making how much angle? It is making an angle theta plus alpha. Now this line is making only, both are only z complex number radius are, z e power I alpha complex number radius also are only. Z complex number angle theta, z e power I alpha complex number angle theta plus alpha. If this is theta, theta plus alpha should be above theta line only, this. And what is this gap? This is theta plus alpha, this is theta, and this gap should be alpha. This gap should be alpha, and this point I will assume z e power I theta. Z e power I theta means r into e power I into theta plus alpha. As we discussed already, we should always move in anti-clockwise direction only. This is this direction of the angle is anti-clockwise direction. Therefore, it matches with option B. Option B, it matches. So we are rotating the angle, theta through in anti-clockwise direction through an angle alpha. So final conclusion you write. Therefore, z is rotated in anti-clockwise direction. Z is rotated in anti-clockwise direction. Z means this. Look here, everyone. Z means this. This Z is rotated in anti-clockwise direction through an angle alpha only. Z angle theta. If Z angle is rotated in anti-clockwise direction through an angle alpha, total degree is theta plus alpha. Through Z. Z means only this line is rotated in anti-clockwise direction through an angle alpha to get theta plus alpha. Through an angle alpha. Syllabus completed. My name is P. Venkat Rao. and my mobile number and mail ID I will give you. When you are preparing from last 25 years GATE solutions booklet or volume 2 booklet, I mean practice questions with the detailed solutions booklet, or any other source when you are preparing, if you have any doubts till before GATE exam, you can mail me or you can use this. Now I will take the doubt session. Those who don't have any doubts, they can leave the session. I'll talk to students one by one, sequentially. First, sequential order, Sri Charan. Sri Charan.
Hello, sir.
Tell me, Sri Charan.
172, sir.
172 na?
Yes, sir.
Fine.
Sir, here you told that it will have no denominator, no, sir.
Listen to me. Actually, criteria, third point I said. Criteria, fourth point. It is not. Suppose the function essential singular point may be completed. Suppose the statement of the given problem does not have any denominator and its a series expansion contains infinite number of negative powers of z minus z naught, then z naught is called essential singular point. Suppose series expansion not possible, no singular point. Tell me no.
Actually, in next page it has denominator, no, sir.
1 minute. Let me check. 1 minute. This is not denominator. Denominator, this 4 by z minus 2. Denominator means something here and something here. This is not a denominator.
In the expansion it has denominator, no, sir. That's why I thought.
No, what I said, did I say in the expansion? Given function I said, not
Okay.
expansion. Given function doesn't have denominator.
Sir, in the expansion, if there is a denominator, there is no pole, sir.
Then it doesn't have any singular point.
No, sir.
Suppose a denominator, there is no singular point. Tell me, there is no polar. I mean, like z minus 2 plus z minus 2 whole square plus z minus 2 whole cube, like that.
No, sir. I'm asking that simple pole will be not there in expansion. I doubt.
No. It will be there. Sometimes it's a series expansion may contain. Please refer the yesterday's Taylor and Lorentz series expansions. Only one simple pole will be there. Only one negative power of z minus z naught. You should not say that simple pole will not be there in the option. Suppose your Taylor series, a Lorentz series is up to here, then this is 1 by z minus z naught is the pole. How can you say that simple pole will not be there in the expansion?
No, sir. I'm asking the doubt.
No. It may or may not be. We should not say it should not be. We should not say it must be. It may or may not be the statement.
Okay, sir.
That's it. Any other?
That's it, sir. Thank you for the class.
Okay. Next, one by one. Next to Shweta. Shweta.
Hello, good evening, sir.
Good evening. Tell me.
Sir, I have a doubt in the question that you gave for homework. The value of integral of e raised to power of z upon z square plus pi square whole square.
No. Which problem? Tell me regarding that.
Yes, I don't know how to solve it using the method that you taught us. So should we take it a partial?
No. That model there it becomes lengthy. That's why you solve that problem using residue theorem. Today I gave this. You observe this. Same problem I taught today. E power z by z square plus pi square whole square.
Yes.
Don't apply integral theorem, integral formula. Residue theorem is comfortable.
Okay. So if I have to do it using the previous method that you taught us, then
if you want, you
using
can
that.
If you want, you can use that theorem, but before that, you need to split into partial fractions. But
That's what I'm asking. Then
1
taking the
minute.
sum of that.
Partial fractions is valid only when the factors are real factors. But for this, the factors are imaginary factors. If factors are imaginary, we should not apply partial fractions.
Okay.
So that's why it cannot be solved using integral theorem, integral formula. In integral theorem, integral formula, whenever you want to split up into partial fractions, there the factors must be real. They should not be imaginary. If
So
imaginary,
then,
we should not split up into partial fractions.
so there I got, but how to solve it using the previous method that you taught us? If we equate the denominator to 0 and then how to do it?
Denominator is equated to 0. You will previous method you cannot solve. See,
We
by
have given the
manipulation.
answer already. Actually, it's minus pi I.
Pardon?
So you gave the answer, so
Using residue theorem, that is the answer. You have to solve that using residue theorem. Using integral theorem by manipulation of the function. Suppose the numerator is z square plus pi square minus z square. Not possible integral theorem, integral formula. Residue theorem only.
okay. And so 135 page number.
Ah,
135.
this is 135.
This one, sir. So most of the questions that we have solved in Taylor series, the expansion that is
See,
given to us.
listen to me. Either it is a Taylor series or Laurent series expansions. Most of the problems can be solved using Taylor series expansions only.
Yes, sir. That's not my doubt, actually. But most of the questions that we have that you have given, they are generally as if that I'm asked to expand it about z is equal to pi, and there is one term, and the coefficient is also some term of z and pi. Are you getting me?
You are talking about this problem or generally?
So generally.
Either it is a Taylor series or Laurent series, the expansions here log 1 minus x. Log 1 minus x I have expanded using those 10 formulas I gave now. Most of the problems will be expanded using some standard series expansions only.
So we have to pay more attention to what point we have to expand about, right?
Yes,
Rather
yes.
than what's given in the question.
Yes, yes.
Okay. So that's what my doubt is. Thank you, sir. Thank you so much.
Any other?
No, sir. Thank you very much.
Okay. Next, Sai Prasanna, 1 by 1. Sai Prasanna.
Sir, good evening, sir.
Good evening. Tell me, Amma.
Sir, I have a doubt in page number 194F.
194F. Tell me.
Sir, I did not understand this problem.
What you didn't understand? Do you know the formulas I gave? Tell me which part you didn't understand. This first step, okay na? This residue of f of z. This second step, okay na?
Second step I need.
Pardon, I am not understanding. Second step you understand or not? This is the formula I gave, no?
Yes, sir, but okay, sir. Sorry, I did not note like z minus pi by 2. I have not written, so I was confused.
Now okay na?
Yes, sir.
Next.
Sir, and also I have a doubt in page number 204F.
Tell me.
Sir, sorry, 203. Sir, when we are solving this problem using other method like simple pole method, then
actually choice is yours. If you want, you can apply limit z10, z tends to z0, z minus z0 into f of z also. But this is comfortable. That's why I have adopted this. There are no restrictions. Whichever you feel. There I gave two formulas. No, whichever you feel more convenient and effective and easy, you can adopt that.
okay, sir. But answer will be the same, right?
Otherwise, method will not be correct. No answers in any method you do, you should get the same answer only.
1 minute, sir. Okay, sir. Thank you.
That's it, Amma.
Yes, sir. Thank you.
Thank you. Next. Please mute yourself, Sai Prasanna. Next. Kartikeya. Kartikeya.
Yes, sir. Sir, can you open page number 213? 213.
Fine.
Sir, it's a general doubt. No, just want to ask if numerator becomes 0 when we put z naught in the numerator.
If numerator becomes 0, then find the order of 0 of z naughts the way we found yesterday.
Yes, sir. Third.
Then you follow the criteria of procedure 3.
Yes, sir. If it's removable singular point, then it is 0.
Residue will be 0. Once you confirm that it is a removable singular point, no need to find residue. It would be 0.
Okay, sir. That's just okay. Sir.
That's it, huh?
Yes, sir.
Okay.
Thank you, sir.
Okay. Please mute yourself, Kartikeya. Next, Satyaprakash. Satyaprakash.
Hello, sir.
Tell me.
Sir, slide 189F.
Slide?
189, sir.
Okay, fine.
Sir, there, why did we exclude z equal to plus or minus pi plus or minus 2 pi like that?
What
is any
is this?
condition given?
What is this n belongs to?
Acha, okay, I missed that statement, sir. Okay, got
Sin
it.
theta is equal to 0, theta is equal to n pi, where n belongs to integers. Integers
sir.
means 0, plus minus 1, plus minus 2, plus minus 3, so on.
Yes,
So
sir,
n
right.
is equal to 0, one singular point. N is equal to 1 plus pi, n is equal to minus 1 minus pi.
Okay, sir, got it, sir.
That's it, huh?
Yes, sir, yes, sir.
Any other?
No, sir, that's it.
Okay, fine.
Thank you.
Please mute yourself. Next, Gopal Sai Krishna. Gopal Sai Krishna.
Hello, good evening, sir.
Good evening, tell me.
Sir, page number 209F. Oh, sorry.
209.
Yes, sir. Sir, sir, ఒక బ్యాక్ సార్ 208. సార్ ఇందులోని ఈ ప్రాబ్లంలోని మనకి సింగులర్ పాయింట్ ఏదో ఎలా తెలుస్తుంది సార్? అంటే
అక్కడ ఏం చెప్పాను, జెడ్ ప్రతి జెడ్ ని జెడ్ మైనస్ జెడ్ నాట్ గా రాయమన్నాను కదా.
ఎస్ సార్, అవును సార్.
ఆ డినామినేటర్ లో జెడ్ మైనస్ జెడ్ నాట్ గా రాస్తే ఇక్కడ చూడు, ఇక్కడ జెడ్ మైనస్ జెడ్ నాట్, జెడ్ మైనస్ జెడ్ నాట్, జెడ్ మైనస్ జెడ్ నాట్ అంటే జెడ్ నాట్ ప్లేస్ లో 0 ఉంది కదా, 0నే సింగులర్ పాయింట్.
అంటే మామూలుగా ఇప్పుడు క్వశ్చన్ లో f of z ఇచ్చినప్పుడు డినామినేటర్ 0.
ఒక్క నిమిషం. ఎసెన్షియల్ సింగులర్ పాయింట్ అంటే ఏం చెప్పాను నిన్న, ఇన్ఫైనైట్ నంబర్ ఆఫ్ నెగటివ్ పవర్స్ ఆఫ్ జెడ్ మైనస్ జెడ్ నాట్ ఉండాలని చెప్పానా.
అవును సార్.
ఇందులో ఇక్కడ చూడు, ఈ లాస్ట్ సిరీస్ లో ఇన్ఫైనైట్ నంబర్ ఆఫ్ నెగటివ్ పవర్స్ ఆఫ్ జెడ్ మైనస్ జెడ్ నాట్ ఉంటాయి కదా, ఎక్స్పాండ్ చేస్తే.
అవును సార్.
అంటే ఇక్కడ జెడ్ నాట్ అదే అనేది ఎసెన్షియల్ సింగులర్ పాయింట్. అది సింగులర్ పాయింట్ ఏ టైప్ అయినా కావచ్చు, పోల్ కావచ్చు, రిమూవబుల్ కావచ్చు, ఎసెన్షియల్ కావచ్చు.
అవును సార్. సార్ తర్వాత నెక్స్ట్ ఇంకోటి ఇదే క్వశ్చన్ లో ఇప్పుడు ఎక్స్ స్క్వేర్ ప్లస్ వై స్క్వేర్ ఈక్వల్స్ టు 1 అని సర్కిల్ ఇచ్చాడు కదా సార్. ఇది ఎక్కడ యూజ్ అవుతాం సార్? అంటే యూజ్ ఆఫ్ ఇన్ఫర్మేషన్ ఇది నెక్స్ట్ క్వశ్చన్ లో కూడా అంతే, 4th లోని సి ఈక్వల్స్ టు ఎక్స్.
సర్కిల్ ఇచ్చాడంటే సింగులర్ పాయింట్, అక్కడ కాచి రెసిడ్యూ థియరం యూజ్ చేస్తున్నాం అంటే దాని అర్థం ఏంటి? సింగులర్ పాయింట్స్ సర్కిల్ లోపల ఉంటేనే రెసిడ్యూస్ వాటి దగ్గర కనుక్కోవాలి అంతే.
అంటే ఇప్పుడు ఆ జెడ్ స్క్వేర్ ఇదే క్వశ్చన్ లో థర్డ్ క్వశ్చన్ లో జెడ్ స్క్వేర్ 1/z-3 అనేది ఉంటే అప్పుడు రెసిడ్యూ 0 అయిపోతుందా సార్? సేమ్ ప్రాబ్లం. థర్డ్
సేమ్ ప్రాబ్లం. టెల్ మీ.
జెడ్ స్క్వేర్ sin 1/z-3 లా ఏమైనా ఉంటే అప్పుడు రెసిడ్యూ 0 అయిపోతుంది సార్, ఎందుకంటే
అలా కాదు ఇప్పుడు అర్థమైంది. దెన్ ఇట్ ఈస్ sin of 1/z-3, రైట్?
అవును సార్. yes.
Then it should be written as z-3 plus 3 whole square, and then z-3 whole square. See, sin of 1/z-3, it will have infinite number of negative powers of z minus z naught, right?
అవును సార్.
So then every z should be in the form of z-3. That's why write this z square as z-3 plus 3 whole square.
అప్పుడు రెండు టర్మ్స్
z-3
వస్తాయి.
whole square plus 3 square plus 2 into z-3 into this series expansion.
Okay. Okay, sir.
But
Okay.
as that is corrected out only, but in the exam up to that much they may not ask.
సరే సార్ అంటే మామూలుగా జనరల్ గా డౌట్
General గా అదే correct. Actually the doubt is very good.
సరే థ్యాంక్ యూ సార్ చాలా హెల్ప్ అయింది సార్ క్లాస్ థ్యాంక్ యూ వెరీ మచ్.
Next Satya Prakash. Please unmute Satya Prakash.
Sir, over sir.
Okay. Next Manideep.
Hello sir.
Tell me Manideep.
Sir, page number 191.
Tell me.
Sir, in this, how you get -5, sir?
1 minute. Just please have a look. We need residue of f of z. F of z means what? Z minus 3 into sine of 1 by z plus 2 residue is required at -2, no?
Yes, sir.
So -2 means z0. 1 by z minus z0. 1 by z minus z0. Z0 is -2. Z minus of -2, z plus 2. Correct?
Yes, sir.
1 by z plus 2 coefficient in the Lorentz series expansion of z minus 3 into sine of 1 by z plus 2, no?
Yes, sir.
Understand or not?
Okay, sir. In z place, -2, -3.
1 minute. We need coefficient of 1 by z plus 2 in the series expansion of z minus 3 into sine of 1 by z plus 2. You understand that?
Yes, sir.
1 minute, wait. Look here. This is z minus 3 into sine of 1 by z plus 2 about z is equal to -2. Same problem, huh?
Yes, sir.
We solved this problem yesterday itself. 1 by z plus 2 coefficient. Look here. 142f. Look here. 1 by z plus 2 coefficient. How much?
-5.
-5. That I have written directly.
Okay, sir. Okay.
Actually, this problem already expanded Lorentz series in the yesterday's class. Lorentz series expansion only. Same answer I took and I have written here. Got it or still doubt?
Okay, sir. Got it. Page 202.
202, na?
Yes, sir. Sir, in this, how did you take z equal to pi by 2 minus pi by 2?
Denominator is equated to 0. Cos z is equal to cos theta 0, theta value 2n plus 1 into pi by 2. Is it clear?
Yes, sir. Clear.
Here cos theta is equal to 0. Theta means what? Z. Are you getting?
Yes, sir.
Z is equal to 2n plus 1 into pi by 2. Where n belongs to?
Integer.
Tell me one starting integer. 0.
0.
Take n is equal to 0. 2 into 0, 0. 0 plus 1, 1. 1 into pi by 2. Next take n is equal to -1. 2 into -1. -2 plus 1 minus pi by 2. Next take n is equal to 1. 3 pi by 2. 3 pi by 2 lie outside. That's why remaining singular points I did not consider. I have considered how many singular points which are lying inside our curve only.
Okay, sir.
That's it, huh?
1 minute.
Hello, sir.
Next one. 1 minute.
Okay, sir.
Manideep completed, huh?
Sir, page number 144.
144.
44, sir. 144.
Tell me.
Sir, in this, how did you take z by 2?
See, statement of the given problem does not contain trigonometric function, hyperbolic function, logarithmic function, exponential function. In all such cases, the given function can be expanded as a Taylor series or Lorentz series using binomial expansion. So binomial expansion is valid in the region mod x less than 1. Yesterday I gave, did you remember?
Yes, sir.
Now, how can I make it as less than 1 here? Divide both sides by mod z. 1 by mod z less than 1. Is it clear?
Okay, sir.
How can you make it as less than 1? Divide both sides by 2. Mod z by 2 less than 1.
Okay, sir.
Target is getting our region in the format of mod x less than 1.
Okay, sir.
That's it.
That's it, sir. Thank you.
Hello, sir.
Next to Sagar.
Good. Yes, sir. Sagar.
Tell me, Sagar.
Sir, 40.
Huh?
Page number 40.
Okay, fine.
Sir, this fourth problem you have given homework, right, sir?
It is differentiable only at the origin. Tell me.
Sir, I solved that, sir. I am getting it satisfies the CR equation, sir.
CR equations are satisfied. At 0, 0, it will satisfy.
Means I am getting Vx, that condition is there, not a CR condition I am getting, sir, that thing. Then it will be entire function, right, sir?
No, man. Look. F of z is equal to mod z whole square means x square plus y square.
Yes, sir.
The real part is u. Is there any imaginary part? No. So ux is 2x, uy is 2y, vx 0, vy 0. CR equations are not satisfied. If CR equations are not satisfied, then you need to check at options. Options are 0, 0. Yet 0, 0, ux 0, uy 0, vx 0, vy 0. CR equations not satisfied, but then we need to check at the points. Those points generally should be assumed from the options. If options given at 0, 0, 1, 1, we need to check there. Now CR equations are satisfied at 0, 0, na?
Yes, sir.
Okay, na?
Yes, sir.
CR equations are satisfied at 0, 0. And ux, uy, vx, vy are constants. Constants means polynomial.
Yes,
So
sir.
which are continuous everywhere. So both sufficient conditions are satisfied at 0, 0. It is a differentiable at 0, 0 only. Both sufficient conditions are satisfied in the neighborhood of 0, 0. It is analytic at 0, 0. Tell me one neighborhood of 0, 0 point. 0.2, 0.3. Okay, na?
Yes, sir.
If I take x is equal to 0.2, then ux becomes 0.4 and uy becomes 0.6. Now CR equation is satisfied in the neighborhood?
No, sir.
No. Then CR, both sufficient conditions are satisfied only at 0, 0. But in the neighborhood, not satisfied. Correct or not?
Sir, if you take both x and y as same number, sir, then it will satisfy.
X and y are same numbers, okay.
0.2, 0.2.
Okay. Let us take x is equal to 0.2, 0.2. Then it is 0.4. This is 0.4. Check it. Ux 0.4, Vy 0. Uy 0.4, Vx 0. Satisfied?
Okay, sir. Got it, sir.
Got it?
Yes, sir. Got it. Sir, actually, what I took was like x square plus I, y square plus 2i, xy I took, sir. That's why I was getting wrong.
No.
Hello, sir. Hello, sir.
Hello, sir.
Sir, I still have doubts.
Hello, sir.
1 minute.
Hello, sir.
Sagar, come.
Hello, sir.
No, sir. I still have doubts, sir.
Wait. I'm talking to Sagar. Tell me.
Sir, 83, sir. Page number 83.
Sequential order, I will call the students. Tell me.
I think 84.
80?
4. Sir, when we need to use this and when we need to use the Cauchy's integral formula, sir? When it is
1 minute. Karu closed here?
No, sir.
Karu not closed, do like this. Karu closed, integral theorem, integral formula, residue theorem. That is only the difference.
Okay.
Karu closed,
okay,
integral
sir.
theorem, integral formula, otherwise in this manner.
Okay, sir. Sir, and 92.
Because the other students are waiting, make it fast. 92.
Yes, sir.
1 minute. Tell me. 92. Sagar.
Yes, sir. In 92, actually, here, in this point, sir, first it was not satisfying, sir.
CR equations are not satisfied.
Yes, sir. Then
but we were asked to find the value of the integral along this curve. This curve is a straight line passing through the origin.
Yes,
and so that is y is equal to x. So we need to check whether it is analytic or not along y is equal to x. That's why I have verified again CR equations along y is equal to x. Along y is equal to x, CR equations are satisfied.
Yes, sir.
Doubt is what? Please make it fast.
Means it is satisfied, then we can continue with the procedure, right, sir? It is analytic.
How can you say that, man? Again, you are asking the same. Both sufficient conditions are satisfied at one point, differentiable at that point. Both sufficient conditions are satisfied in the neighborhood, it is analytic. Here, both sufficient conditions are satisfied along this line only. So it is a differentiable along this line. Suppose both sufficient conditions are satisfied in the neighborhood of this line. Neighborhood of this line means this area outside this region.
Okay, okay.
Outside this region means 0.72, 0.92 like that. Is it clear?
Yes, sir. I got it, sir.
Is it clear?
Yes, sir. Yes, sir. Got it, sir.
Any other?
Sir, one more last dot, sir. Sir, 116.
116?
Yes, sir.
Tell me.
Sir, here this fraction you have made shortcut, right, sir? Partial fraction shortcut. That thing it will apply only when it is 1 and 1 same denominator, sir.
One minute. It is applicable only when degree of each and every z is 1. Then only it is applicable.
It is z plus 1 into z minus 3. Then also it is applicable, sir.
Applicable.
Okay, okay. Sir, next page, sir. Sir, here f of 1 equal to what? How you took, sir?
See, f of z is 1. Look here, f of z is 1. Take z is equal to 1, f of 1 is 1. Here, second case, f of z is equal to 1. F of minus 1 is equal to 1. Got it what I'm saying?
Okay.
That's why I've clearly mentioned. Is it clear?
Sir, if we will not get to the points like if we not get the value, sir, like if we
suppose, 1 minute, man. Suppose 3 is there, f of 1 is 3. 5 is there, f of 1 is 5. Suppose z square is there, f of 1 is 1 square. Z square plus 5 is there, f of 1 is square plus 5.
Yes, sir. This thing I got it, sir. Sir, previous problem you have solved one problem.
डाउट पूछेंगे क्या होते हैं?
They are waiting. Please.
Hello, sir.
Back, sir. Back.
Sir, that's it.
Sir, one formula, one question was there, sir. Z cube.
Okay, it is become Z cube. Which one?
Previous.
रख डालो कहीं को बच्चे.
Please tell me the question number. Otherwise, it is typical, Mr. Shri.
Sir, sorry, sir. I don't know the numbers actually. Sir, what is my doubt is, sir, like if there are three roots in denominator. Yes, this one, sir. If there are three roots and if it is not solvable like this, then how to find the roots, sir?
See, for any equation, we are able to find the roots. No, these are polynomials only. Numerator, denominator, we must have polynomials. Otherwise, Cauchy residue theorem we can apply.
Okay, sir.
Not possible means denominator, numerator, polynomials only. If they are sin z, cos z, tan z, Cauchy residue theorem.
Okay, sir. Okay, thank you very much.
Thank you.
Hello, sir. Hello, sir.
Next, Nadima.
Nadim. Sir, yesterday while I was talking, I అనుకోకుండా పోయింది సార్ హాస్టల్ నుంచి మీరు తీస్తున్నారు 2 days. 2 days నుంచి అంటే హాస్టల్ నుంచి పోతుంది. అదే ప్రాబ్లం ఐ డౌట్ ఉండే నిన్న లారెన్స్ సిరీస్ పేజ్ నెంబర్ అంటే లారెన్స్ సిరీస్ ప్రాబ్లం చెప్పేటప్పుడు అది వెళ్ళలేదు సార్ ఒకసారి చెప్పండి.
అరే పర్లేదు ప్రాబ్లం చెప్పు చాలు.
అంటే ఫోర్త్ ప్రాబ్లం లారెన్స్ సిరీస్ లో ఫోర్త్ ప్రాబ్లం లారెన్స్ సిరీస్ పేజ్ నెంబర్ అంటే నిన్న సడన్ గా అడుగుతా ముందే అది ఎవరో వేరే అతను మాట్లాడుతున్నాడు, సడన్ గా అప్పుడు తీసేశారు, నాకు అప్పుడు అర్థం కాలేదు.
టెల్ మీ ఇదేనా?
ఇదే ఇది ఇది ఇంకా 2 అంటే అప్పుడు కనెక్ట్.
పర్లేదు. ముందు డౌట్ ఏంటి ఇక్కడ మనకి సిరీస్ వి నీడ్ అబౌట్ z ఈజ్ ఈక్వల్ టు -2 కదా. అంటే మనకి అబౌట్ ఒక పాయింట్ ఇస్తే ఆ పాయింట్ లెఫ్ట్ సైడ్ తీసుకోవాలి. అంటే ఎంత? z+2. అంటే సిరీస్ ఎక్స్పాన్షన్ z+2 ఫార్మాట్ లో రావాలి. అందుకని z+2 ని t అనుకో. z ఎంత అయింది? t-2 అయింది. ఓకేనా? బట్ z-3 కనుకోండి, ఎందుకంటే ఇక్కడ z-3 ఉంది కాబట్టి. t-5 అర్థమైంది ఎంతవరకు? ఇక్కడ తీసుకో z-3 ఇంటూ sin of 1/z+2. z-3 అంటే ఇప్పుడే కనుక్కున్నాం, t-5
మొత్తం.
ఇది z+2 అంటే t కదా ఇక్కడ. సో ఇది ఈ t-5 అలాగే ఉంది. sin x ఎక్స్పాన్షన్ తెలుసు కదా నీకు.
1 - x³/3.
నో sin ఇది దీని ఈ 1/2 ని x అనుకో. sin x ఎక్స్పాన్షన్ వచ్చి x మైనస్ x3 ఫ్యాక్టోరియల్ ప్లస్ x⁵5/5 ఫ్యాక్టోరియల్. ఇదన్నీ రాశాను. ఈ బ్రాకెట్ లో ఉన్న ప్రతి టర్మ్ ని t చేత 5 చేత మల్టిప్లై, ఫస్ట్ t చేత మల్టిప్లై చేసి ఫస్ట్ బ్రాకెట్ లో రాసాను, మైనస్ ఇంటూ 5 చేత మల్టిప్లై చేసి సెకండ్ బ్రాకెట్ లో రాశా. ఓకేనా? ఇవన్నీ మళ్ళీ సెపరేట్ గా ఇలా సెపరేట్ చేసేసా. అర్థమైందా?
ఇప్పుడు మనం ఆ z వాల్యూ మనకి z0 వాల్యూ
t వాల్యూ మనం ఎజ్యూమ్ చేసుకున్నాం కదా, ఇది t వాల్యూ z+2, దాన్ని తెచ్చి ఇక్కడ సబ్స్టిట్యూట్ చేసా, అయిపోయింది.
సార్ ఇంకోటి సార్, ఇప్పుడు గేట్ కి అంటే ఏమేమి వస్తాయి మెయిన్ టాపిక్స్? నాకు కాంప్లెక్స్ వేరియబుల్ నాకు
ఇది చెప్పేది కన్స్ట్రక్షన్ ఆఫ్ అనలిటిక్ ఫంక్షన్ ఉందా, అందులో మోడల్ నంబర్ 2 ఉంది కదా, u ఇస్తే v కనుక్కోవటం, v ఇస్తే u కనుక్కోవటం. అదొకటి కాచీస్ ఇంటిగ్రల్ థియరం, కాచీస్ ఇంటిగ్రల్ ఫార్ములా, కాచీ రెసిడ్యూ థియరం, పక్కా 2 మార్క్స్.
ఓకే సార్,
అంతే
సార్. ఇప్పుడు మనం ఇప్పుడు అంటే రెసిడ్యూ ఇంటిగ్రల్ కి డిఫరెన్స్ ఏంటి సార్? అంటే అది ఉట్టి మనం ఫార్ములా పెడితేనే వస్తుంది కదా సార్? అంటే ఇంటిగ్రల్ కంటే రెసిడ్యూ మనం అన్ని రెసిడ్యూలను చేసేయచ్చు కదా సార్?
ఏది
అంటే కాచీస్ రెసిడ్యూలో మనం ఉట్టి ఫార్ములా
రెసిడ్యూ థియరం, రెసిడ్యూస్ కనుక్కోవటం వస్తే కాచి రెసిడ్యూ థియరంలో 90% అయిపోయినట్టే, 95%. ఇప్పుడు కాచి రెసిడ్యూ థియరం ఏంటి? 2πi ఇంటూ సమ్ ఆఫ్ ద రెసిడ్యూసే కదా. రెసిడ్యూస్ కనుక్కొని 2πi ఇంటూ సమ్ ఆఫ్ ద రెసిడ్యూ అంటే కాచి రెసిడ్యూ అయిపోయినట్టే కదా. అది డౌట్ ఏంటి?
అదే ఇప్పుడు ఫర్ ఎగ్జాంపుల్ ఇప్పుడు పెద్ద ఒక వేరియబుల్ ఇదే ఉంది సార్, z - sin z/z³. ఇది మనం టైలర్ సిరీస్ నుంచి ఆ రెసిడ్యూలో మనం కన్వర్ట్ చేయాలంటే అది డైరెక్ట్ వచ్చేస్తుంది కదా సార్?
రెసిడ్యూ డైరెక్ట్ వచ్చేస్తుంది. అన్నిటికీ సిరీస్ ఎక్స్పాన్షన్ పాసిబుల్ కాదు కదా, అప్పుడు ఫార్ములా యూజ్ చేసి ఫైండ్ అవుట్ చేయాలి. సిరీస్ ఎక్స్పాన్షన్ వస్తే ప్రతిదానికి సిరీస్ ఎక్స్పాన్షన్ రాదు. ఓకేనా?
ఓకే సార్, థ్యాంక్ యూ సార్.
ఉన్నాయా?
థ్యాంక్ యూ.
ఓకే అమ్మా,
ఓకే, థ్యాంక్ యూ సార్.
నెక్స్ట్ అతుల్ మీనా.
హలో
నెక్స్ట్ సీక్వెన్షియల్ ఆర్డర్ అతుల్ మీనా, నెక్స్ట్ లక్ష్మీ ప్రభా, నెక్స్ట్ ఆకాంక్ష. ది సీక్వెన్షియల్ ఆర్డర్ నెక్స్ట్ అతుల్ మీనా, నెక్స్ట్ ఆకాంక్ష.
సార్ యూ గివ్ వన్ హోంవర్క్ ప్రాబ్లమ్, ఇంటిగ్రల్ e to the power z divided by z² - 1 dz in the end vertices of square.
No. Could you please tell me which topic so that I will explain?
Sir, it's Cauchy integral.
Cauchy's integral.
Sir, just after that GATE EC 2018 question in which 2 simple poles are given. Just after that question, you give one homework problem.
Residue theorem, integral theorem, integral formula.
Integral theorem, integral formula.
This one,
no sir, after this. That GATE easy problem in which 2 points are given.
This one,
after this sir, this problem number 8.
This one,
sir, okay sir, I got sir, I actually note wrongly answer.
Okay na?
Okay sir, thank you.
Any other?
No sir.
Okay, good. Next Akansha, followed by Atul Meena completed. Then mute yourself, Akansha. Next Venkat Sai. After Akansha, Akansha, tell me.
Yes, sir. In this question, can we do it by today's residual theorem?
Yes, why can't?
So by expanding e to the power x, or we have to like take residue of
One
each.
minute. But you cannot find residues. Expansion not possible because numerator we can expand, but what about denominator? We can't simplify, no?
So, but in some of the question when it was 1 by z, then it can be cancelled.
Amma, let me speak. Series expansion possible, expand. After expanding, multiply both sides, multiply with 1 by z square minus 1. Residue is after expansion, will you be able to get 1 by z minus z naught? That is fine. But 1 by z square minus 1 is there, numerator 1 plus z square. How can you find 1 by z minus z naught form? Not possible. If possible, write the series expansion. Series expansion not possible, but we can find residues by using residue
yes,
formula I gave.
Yes, sir. Yes, sir. Yeah, sir, that's what I was. And sir, some more doubt. So, yes, sir. In we are doing that Cauchy's integral formula and residue
all integral theorem, integral formula problems can also be solved using residue theorem and vice versa.
Yes, sir. That I
but
understand.
sometimes integral theorem, integral formula, sometimes residue theorem problems may not be solved using integral theorem, integral formula. Suppose tan z, it is it doesn't contain denominator z minus z naught. Correct or not?
Yes, sir. Yes, sir.
Those problems can be solved using residue theorem only, because we don't have z minus z naught now.
Yes, I understood. So I'm just asking that in these two formulas that fz should be analytic, then only we can proceed.
Yes, otherwise not possible. F of z must be analytic.
Including the denominator part, that singular part, or excluding
1 minute.
That?
In Cauchy's integral, which theorem you are talking about?
Same both.
Integral theorem, whole function f of z is analytic, and integral formula f of z by z minus z naught. Only numerator f of z is analytic.
Okay. And residue?
Residue whole f of z is analytic everywhere. And I mean inside the given curve.
Yes, yes. So that where phi of x by psi dash of x.
That we can use in case of simple pole. Simple pole, two formulas I said.
Yes, sir, that I understood. But in that we are finding residue.
Your choice. In case of simple pole, you can use any one.
Yes, sir. It is making simpler question.
Same answer. 1 minute. This one you are asking now. This one is the simple pole. This one also simple pole. In this, by applying any formula, you will get the same answer in case of simple pole.
Yes, sir. In this phi x by psi dash x, we need not multiply it by z minus z naught like we were doing previously.
No. We should not multiply anything directly.
Oh, if we see that its denominator is equal to 0, then we will directly.
No need to simplify, no need to multiply, directly substitute. Phi of z by psi of z, numerator phi of z, denominator psi of z, you assume.
Then sir, that question that z square minus pi square whole square, e to the power z by z square plus pi square whole square. Why didn't we did that with this using phi x by
That is not a simple pole, madam. That is simple pole.
Oh, okay.
Correct or not? That is valid only in case of simple pole.
Yes.
Correct or not?
Yes, I got it. Sir, you clarify more doubts. Then at last I will ask some questions. Okay. Because I have seen those solutions I've seen, but I'm not able to understand written form. I want just your explanation.
Okay.
Okay, I will be waiting.
Next. Venkat Sai, please unmute yourself.
Hello, sir. Good evening.
Venkat Sai, tell me.
Sir, slide number 154, sir.
154. Tell me.
Sir, ఇది కాదు సార్ నాన్ ఐసోలేటింగ్ ఇదే సార్ నాన్ ఐసోలేటింగ్ సింగులర్ పాయింట్ తీసుకున్నాం కదా సార్ ఇక్కడ z ఈక్వల్ టు ప్లస్ ఆర్ మైనస్ 1 ప్లస్ ఆర్ మైనస్ మనం 0 దగ్గర నాన్ ఐసోలేటింగ్ సింగులర్ పాయింట్ అని చెప్పారు సార్.
అవును
సార్, ఒకవేళ మనం +1 ని కన్సిడర్ చేసుకుంటే అది ఐసోలేటింగ్ అవుద్దా నాన్ ఐసోలేటింగ్ అవుద్దా సార్?
ఇప్పుడు +1 తీసుకున్నావు, దాని చుట్టూ నువ్వు ఒక రేడియస్ చెప్పు. రేడియస్ వెరీ వెరీ నియర్ టు 0 ఉండాలి. ఇప్పుడు 1 సెంటర్ రేడియస్ 0.0001 అంటే 1 సెంటర్ రేడియస్ 1.00001 అంటే దాని లోపలికి 2 గానీ 1/2 గానీ రావు కదా.
ఓకే సార్. ఓకే సార్.
అన్ని ఇవన్నీ నాన్ ఐసోలేటెడ్ ఎక్సెప్ట్ 0.
అంటే ముందు ఒక ఎగ్జాంపుల్ లో మనం నైబర్హుడ్ అంటే 0.2 0.3 రేంజ్ లో కూడా తీసుకున్నాం కదా సార్. సో ఇక్కడ 0.5 కూడా ఇంక్లూడ్ అవుతుంది.
కాదు, అదేదో రఫ్ గా ఎక్స్ప్లెయిన్ చేయడానికి చెప్పాను. జనరల్ గా నైబర్హుడ్ అంటే డెల్టా నైబర్హుడ్ మెన్షన్ చేయకపోతే మాత్రం ఏ నైబర్హుడ్ అని తీసుకో. జనరల్ గా ఇక్కడ నైబర్హుడ్ అంటే డెల్టా నైబర్హుడ్.
ఓకే సార్.
నెక్స్ట్
అంతే సార్. థ్యాంక్ యూ సార్.
ఓకే,
మీ టీచింగ్ చాలా హెల్ప్ అయింది సార్. థ్యాంక్ యూ.
ఓకే, థ్యాంక్ యూ. నెక్స్ట్ వెంకట్ సాయి, ప్లీజ్ మ్యూట్ యువర్ సెల్ఫ్. మణిదీప్ కంప్లీటెడా? రోషన్ అగర్వాల్.
Hello, good evening, sir.
Roshan Agarwal, tell me.
Sir, I just wanted a clarification. Could you open 197F, sir?
Fine. Tell me.
Sir, I just wanted to know, means like we should reduce the use of L hospital, no, sir? Means like minimum use.
Yes.
Sir, then I just wanted to tell, sir, means like here if we note, then this z, if we divide in the numerator, then it is cos z plus sin z by z. Then without L hospital we can use, no sir, the sin z by z, limit z tends to 0, it will be 1, sir. Then
where is sin z by z as z tends to 1?
Sir, it is limit, no sir. Sir, this z in the numerator, sir, that we have got, no, z into 1 plus e to the power z.
Fine.
That if we divide in the denominator, then this z cos z will become cos z plus sin z by z.
Okay, no issue.
No sir, I wanted to just ask, means like
no, that is correct. We can manipulate, provided we can manipulate the way you said it is correct.
Okay, sir.
That's
it. Means I wanted to ask, means like we should minimize the use of L hospital. I just wanted to...
Yes, correct, 100% correct. But this is simple, that's why I've done directly. That you feel comfortable, you can apply, no issue.
Okay, sir. Okay, just clarification.
Choice is yours. Even in calculus also, you can do like that if you want.
Okay.
Hospital rule. But one thing, at that point, your function must be continuous. That you should keep in mind.
Okay. Okay, sir. Okay, that you told. Okay, sir. Okay, got it, sir. Thank you, sir. Thank you.
Okay.
Hello.
Who is this?
Sir, Lakshmi Prabha.
Tell me, Amma.
Sir, thank you, sir. I understand the concepts and you teach very well, step by step. Thank you, sir.
Thank you very much.
Sir, I want to see the page number 218F.
218F.
Sir, not this one, I think. Before that, 17. Okay, sir. Sir, the sum is given z by z plus 2, but the sum derived for z plus 3.
By mistake I have taken, it is z plus 3 only.
Okay, sir. Okay, sir. Thank you so much, sir.
Welcome.
Thank you, sir.
Next, Manideep, completed?
Hello, sir.
Manideep, not yet completed.
Sir, one doubt.
Tell me.
Sir, 219.
219. Fine.
Sir, in this out of the circle radius also.
How outside the circle?
Yes, sir.
See, what is this greater than 4 square?
Yes, sir.
Listen to me. X minus h whole square plus y minus k whole square is equal to r square. Point lies on the circle. x minus h whole square plus y minus k whole square greater than r square, point lies outside the circle. X minus h whole square plus y minus k whole square less than r square, point lies inside the circle. Here greater than r square, no, greater than means outside, less than means inside, is equal to means on.
Okay, sir.
That's it, Manidip.
Sir, next page. Graph, next page. Sir, in this, how you get alpha, theta plus alpha?
See, this is what is the complex number? Z is equal to Re power I theta. Z is equal to Re power I theta is one line that is making an angle theta with x-axis. Means this first line. Okay, na?
Okay, sir.
That is fine. Now, but we want Z into e power I alpha. Z into e power I alpha. So multiply both sides of this equation by e power I alpha. Z into e power I alpha is r into e power I into theta plus r. Same here r, here r. In Z r is there. Here also e power I theta. Here e power I into theta plus alpha. Means same theta is extended, alpha angle extra.
Okay, r equal to theta plus alpha.
Correct or not? Alpha angle extra is rotated, no? Z is Re power I theta. It is making with x-axis with theta angle. But ZG power I alpha is same only with an angle theta plus alpha. Same line, if it is rotated, this same line, this is theta line angle. Same line is rotated anti-clockwise, it is reaching Q. So that making extra angle alpha. Total angle theta plus alpha. Is it clear or not?
Okay, sir. Anti-clockwise. Clear, sir.
That's it.
No, okay, sir. That's it.
Hello, sir.
Sri Kiran, tell me, Akansha.
Hello.
Sri Kiran, tell me.
Hello, sir.
Tell me.
Sir, in our homework, sir, sin z by z cube.
Adi pool of order 2.
Sir, adi answer enti sir adi?
Pool of order 2.
Removable singularity ani icharu kada sir answer.
By mistake అని చెప్పాను, నేను లాస్ట్ లో కరెక్ట్ చేశాను. పోల్ ఆఫ్ ఆర్డర్ 2.
Sir, okay. Sir, ఇంకోటి sir. Sir, f of z equal to 2z cube plus b into mod z square, sir. Mod z cube.
One minute అయ్యా, నాకు అర్థమైందిలే నువ్వు చెప్పేది. 2z³ plus p into mod z whole square. నీకు చెప్పాను కదా, ప్రతి పాలినామియల్ కంటిన్యూస్ ఎవ్రీవేర్ కదా, అనలిటిక్ ఎవ్రీవేర్ కదా.
sir.
Z పవర్ ఎనీ నాన్ నెగటివ్ ఇంటీజర్ ఈజ్ ఏ కాంప్లెక్స్ పాలినామియల్, కరెక్టేనా? ఇది అనలిటిక్ ఎవ్రీవేర్ కదా.
అవును సార్.
ఇది అనలిటిక్ అవ్వాలంటే ఏంటి? మాడ్ జెడ్ అనలిటిక్ కాదు అంటే ఇది మాడ్ జెడ్ ఉండకూడదు. మాడ్ జెడ్ ఉండకూడదు అంటే బి 0 అయితేనే కదా.
కానీ సార్ అంటే క్వశ్చన్ లో ఓన్లీ ఎనలిటిక్ అడిగింది కదా సార్, ఎవ్రీవేర్ ఎనలిటిక్ అనలేదు కదా.
అవును, అది అసలు అది ఎవ్రీవేర్ కాకపోయినా అసలు ముందు అది అనలిటిక్ అవ్వాలంటే బి 0 అయితేనే కదా. అసలు మాడ్ జెడ్ ఎక్కడ అనలిటిక్ కాదు ఒక్క పాయింట్ దగ్గర కూడా. ఇట్ ఈస్ డిఫరెన్షియబుల్ ఓన్లీ అట్ 0, 0. ఆల్రెడీ చెప్పాను నేను, మీకు ప్రాక్టీస్ చేయమని ఇచ్చాను చూడు బిగినింగ్ లో. మాడ్ జెడ్ హోల్ స్క్వేర్ అని ఇచ్చుంటాం మిమ్మల్ని చూడు. అంటే అది డిఫరెన్షియబుల్, అది అనలిటిక్ కాదు. అంటే అనలిటిక్ పార్ట్ 2z³ కదా.
ఓకే అంటే
అనలిటిక్ కావాలంటే ఖచ్చితంగా బి మాడ్ జెడ్ స్క్వేర్ అనలిటిక్ కాదు, అది ఓన్లీ డిఫరెన్షియబుల్. అనలిటిక్ కావాలంటే ఆ bz స్క్వేర్ పార్ట్ 0 అవ్వాలి. అర్థమైందా?
థ్యాంక్ యూ.
Hello, sir. Sir, 196 page number.
Tell me, Amma. Next, several other students also waiting. 1 minute, Amma. How many doubts you have?
Sir, only one. Sir, I'm not Akansha. Sir, I'm.
Tell me. Varshana?
No, sir. Shraddha, sir.
Tell me.
Sir, here that 8 question, sir, how only one pole z is equal to one pole only?
See, 1 minute, Amma. We were asked to find residue at z is equal to 0. Correct?
Yes, sir.
You only tell me z becomes tan z. Z is equal to tan z. Z value becomes tan z only when Shraddha Z. Your name is Shraddha Patela?
Hello?
Z is equal to minus tan Z.
Yes, sir. Yes, sir.
Z becomes tan Z only when Z is equal to 0. Other than Z is equal to 0, Z cannot be equal to minus tan Z.
Okay, okay.
That's
Yes.
why I mentioned the above condition is valid only when Z is equal to 0. Means Z value is equal to minus tan Z only when Z is equal to 0.
Yes, sir. Yes, sir. Got it, sir.
Got it, Amma?
Yes, sir. Yes, sir. Got
Any
it.
other?
No, sir. No, sir.
Okay, thank you. Varsha?
Hello,
Varsha?
Sir, yesterday's homework, no, sir.
Little bit loud, Amma. Voice is not audible to me.
Sir, hello.
Tell me.
Sir, yesterday's
Very low, Amma.
homework,
Your voice, mobile volume increase.
Sir, it's high, sir. Yesterday's homework, no, sir. 1 minus cos z by z square.
Now it is fine. 1 minus cos Z by Z square. Tell me.
Sir, that is actually pole of order 1, no, sir.
No, Ma. That is removable only. Look. 1 minus cos Z by Z square.
Yes, sir.
1 by Z square, 1 minus cos Z expansion, 1 minus Z square by 2 factorial plus Z power 4 by 4 factorial, so on, right?
Yes, sir.
1 by Z square, 1 minus 1 plus Z square by 2 factorial minus Z power 4 by 4 factorial minus plus Z power 6 by 6 factorial, so on. This cancel, Z square cancel. Minus Z square by 2 plus Z power 4 by 6. Show me where do we have negative powers of Z minus Z naught.
Sir, we are not having. No.
So there are no negative powers of Z minus Z naught.
Oh, okay.
Is it clear?
Yes, sir. Like that, sir. Okay,
Series
sir.
expansion possible. Always give the first priority for series expansion only.
Yeah, sir. I just directly went like 1 minus cos z, then phi of 0, like that I substituted, sir.
Like that also you can do, same answer you get.
No, sir. Then I'm getting first phi of z is equal to 1 minus cos z, then phi of 0 equal
1
to
minute.
0. Yes.
Like that also we get the same answer. Phi of Z is 1 minus cos Z. Then you need to find phi dash of
Square, no, sir.
phi of 0, 0, right?
Yes.
Phi dash of Z is sin Z. Then phi dash of Z, 0, 0. Phi double dash of Z is cos Z. So phi double dash of 0 not equal to 0. Therefore, Z is equal to 0 is a 0 of order 2. Order of 0 is denoted by n. But denominator Z minus Z naught whole power m. What is m value? 2.
2.
M is equal to 2, n is equal to 2. What type of singularity it has?
Removable singularity.
And the same thing I said.
Yeah, sir. Now I understood, sir. Thank you.
That's it, Amma?
Yeah, sir.
Okay. So I'm going to end the session if anybody is there. Varsha not yet completed.
Yes, sir. Completed, sir.
Okay, Akansha. Tell me so that I can end the session. Akansha, tell me.
Yes, sir. Sir, there are some previous year question 2, 3.
Tell me. Do one thing. You can mail me. I'll send the solutions.
Sir, I've seen the solution, but I couldn't understand.
Tell me.
Sir, one question is like 1 by 2 pi I integration of real z dz.
1 by 2 pi I into integral real
z dz.
No issue, Ma. Here 1 by 2 pi I into real part of z means x.
Yes, sir.
Dz means dx plus I dy. You can solve now.
Okay. Means we just have to separate and
no, convert it, unable to solve, convert into polar coordinates. What are polar coordinates? Z is equal to re power I theta. Do you remember?
Yes, sir. So then cos and sine.
Z is equal to re power I theta. In polar coordinates, x is equal to r cos theta now.
Yes, yes.
So x value r cos theta. Real part of z means x. X value r cos theta. Z is equal to re power I theta. What is dz value?
Yes, sir. Yes, sir. Understood.
Okay, Namma.
Yes, sir. So next question is like if z is given 1 plus 1 minus z means it's a series power series 1 plus 1 minus z plus 1 minus z whole square, and we have to find
Tell me f of z is equal to correctly. F of z is equal to
1 plus 1 minus z plus 1 minus z whole square. Dot. So we have to find f of z. So, like reverse.
1 minute, I know the question. Please wait. Plus sona.
So square. So on.
This is, what is this formula? Yesterday I gave 1 minus x whole power minus 1 is 1 plus x square plus x cube plus 1. So this is x.
Okay, we have to just substitute in place of x.
1 minus x. X means 1 minus z whole power minus 1. 1 minus 1 plus z whole power minus 1. 1 by z. Got it what I said?
Yes, sir. Yes, sir. So last doubt. Yesterday I asked that e to the power z is a periodic with a period of.
Yes, Amma, I will let you know. Just 1 minute. Listen to me. F of z is equal to e power z. See, f of z plus t. F of z plus t is equal to f of z. It is periodic function. Got it? Definition? Yes. Now look there. Substitute z is equal to z plus 2 pi. Z is equal to z plus 2 pi. 2 pi I amma. Sorry. Substitute z is equal to z plus 2 pi I. Okay na?
Why 2 pi I?
Because I want to check whether it is a periodic function. Because
that is for 2 pi only.
Look. E power 2 pi I value cos 2 pi plus I into sin 2 pi. Correct or not?
Yes, sir. Yes, sir.
Then what is the value of e power 2 pi I? 1 cos 2 pi 1 sin 2 pi 0. Is it clear or not?
Yes, sir. Yes, it's clear.
So e power z into e power 2 pi I. E power z into what is the value of e power 2 pi I? 1. Same answer we get. F of z plus t is equal to f of z. So what you need to think is z should be added. Z plus how much? Z plus how much becomes the same function again. You have to think and write, because we all know it is the standard result. E power 2 pi I value 1. So e power z into e power 2 pi I. E power 2 pi I 1 only. Bases same, powers will be added.
Okay, sir. So we don't have to study bilinear transformation.
No transformation, amma. You are given f of z. What you need to think is z should be written as z plus how much. Z plus how much will become same function only. You have to think and write.
Okay. And sir, you said that analytic at a point and analytic everywhere. So we have not done any question of analytic at any point.
See, practically analytic at any point function not possible. Any function which is analytic at any point, by default it is analytic everywhere only. Practically we don't have any function which is analytic at a point. Any function which is becoming analytic at a point, by default it is analytic everywhere only. Got it what I am saying, Amma?
Yes, sir, got it. Yes, sir.
Got it what I am saying? Practically there is no any function which is analytic at one point.
Yes, sir,
That's why we did not discuss that point, that method. Any function which is becoming analytic everywhere, no function can be analytic at one point only. Any function which is analytic at any point, by default that is analytic at all points. So that is entire function only.
Okay, sir. Okay, sir. Rest I will send you.
Fine. Got it? Any other?
Oh, sir, it's all right. Thank you. Thank you, sir.
Still you have any doubts? I gave my mobile number. No, you can
Yes,
WhatsApp.
sir. Yes, sir. Yes, sir.
Hello,
I'll
sir.
send the solution. Huh? Okay. Bye.
Sir. Hello.
Should I end the session?
Hello.
Who is this?
Sir, Varsha, sir.
Tell me, Amma.
Sir, can you please tell me about simple connected domain and multiple connected domain?
I said no already. Simple connected region means there are no holes inside the paper. Suppose you take one plain sheet of the paper and squeeze that paper, and that plain sheet of the paper, does it become a point or not?
Yes, sir.
You take one plain sheet of the paper and squeeze, and I mean press that paper. After squeezing that point, finally it becomes one point, no?
Yes, sir.
Then it is simple connected region, means area inside the plain sheet of the paper.
No, sir. My doubt is that simple connected curve and simple connected domain, is it same?
Simple closed curve. Simple connected curve we don't have. Simple closed curve. We don't have simple connected curve, simple connected domain. Simple closed curve is there. Simple connected domain is there.
Sir, is both same? I can't understand.
Both not same, Amma. First of all, you are asking, tell me the difference between simple connected domain and simple connected curve. We don't have simple connected curve. We have simple curve, simple closed curve, simple connected domain.
Okay. Simple curve, simple closed curve.
Simple curve, simple closed curve, simple connected domain is there.
Okay, sir, understood.
Simple curve means any plane curve like this. Simple curve means like this. Simple closed curve means closed curve does not intersect itself. Simple connected domain means a plain sheet of the paper which can be shrunk to a point. Means after shrinking the paper, it has becoming one point, that is simple connected domain.
Okay. Then
I mean plain sheet of the paper having no holes on it, that is a simple connected domain. Is
okay.
it?
Then multiple connected domain, sir?
Multiple connected domain, at that time I thought no. There are some holes inside the paper. You take one paper, this is a paper, these are the holes of the paper.
Okay, sir, understood now.
Now this is simple connected. Simple connected means plain sheet of the paper. No holes on that. Multiple connected domain means a plain sheet of the paper having some holes inside the paper.
3D. Okay, sir, understood.
Is it clear, Amma?
Yes, sir.
Should I end the session?
Yes, sir. Yes, sir.
Varsha?
Yes, sir. Yes, sir.
Still you have any doubts, you can WhatsApp. I'm going to end the session. Have a doubt, you can ask.
Okay, sir.
No doubts, sir?
No, sir. I'll
Okay.
WhatsApp if I have.
Okay.